Hi, welcome to Coding Bootcamp's YouTube channel. Subscribe now and join our live stream session later. See you.
Hey guys, we're going to be talking about the course Introduction to Linux OS offered by codingbootcamps.com. So before we talk about that, let's talk about the instructor of the course, which is going to be me, Kevin Downs. I'm a Red Hat certified system administrator, and at my current job I'm in charge of administering hundreds of servers running on different Linux distributions. I work as a Unix system administrator, supporting several large enterprise level clients with IBM across multiple different environments. As an RHCSA, I'm pretty adept at Linux programming for managing both personal and server Linux systems. Currently, I'm pursuing my Red Hat Certified System Engineer, as well as some DevOps. Let's go ahead and check out our PowerPoint for this course. So as far as prerequisites go for this course, you need absolutely no prerequisites, okay? No prior knowledge, no classes, or no Linux knowledge is necessary for this course. Everything you need to know, we're going to be able to teach you and guide you through all of this course. Some topics we're going to cover in this course are going to be very high level, okay? So we're not going to go too in depth. We're going to give you the very basic knowledge that you need to know on these. We're going to introduce you to Unix. We're going to show you some basic user commands. We're going to go over some text editing, such as VI and Vim. We're going to go over UNIX processes. We're going to talk about the file system and how it works and how the hierarchy is set up. We're going to introduce you to some shells such as Z shell and fish shell, as well as the default bash shell. We're going to go over multitasking and batch processing. We're going to discover some file processing utilities. We're going to go over the very important topic of backing up files using CPIO, tar, gzip, and more. And then we're going to introduce you to some desktop environments such as KDE, Debian, Ubuntu, and others. So what's the takeaway you're going to be taking from these courses? So anything you learn in these courses is going to be highly valuable that you can take in with you to your career, such as a job as a developer, a consultant, an IT specialist, or even a sysadmin. Some of the other courses available that can be followed up with this class is going to be Learn PHP Programming, Intro to Linux Bash Scripting, which is going to be another course taught by myself, Linux Management for System Admins, which again is going to be a course that I'll be instructing, and Intro to HTML and CSS. All of these courses are available at coding-bootcamps.com. Be sure to follow us on social media to see all the different courses that are available. And guys, I'm really hoping that I see you on this course and on the next session for this video and for this course of Introduction to Linux OS. Hey guys, welcome to Introduction to Linux OS or Operating System. My name is Kevin Downs. I'll be your instructor for the series. A little bit about myself. I'm a Unix system administrator for IBM. I serve and administer hundreds of different servers for multiple clients who are all enterprise level, and it's across multiple different environments. I have my RHCSA, which is Red Hat Certified System Administrator, and I'm also pursuing my RHCE, which is Red Hat Certified Engineer, as well as some DevOps stuff. Let's go ahead and get started here with Session 1 of Introduction to Linux OS. Here it is again, some things about myself. In case you thought I was lying, here it is in writing, in case you wanted to call me on my fib. So let's go ahead and go over what we're going to outline today. First off is going to be Introduction to Unix, Design Philosophy, System Components, the Shell and Command Entry, and finally installation and setup. And hopefully that's where we'll spend most of our time, so I can kind of walk you through how to set up your lab environments. Alright, here we go. Let's get started. Introduction to Linux and Unix. Linux is a Unix-like operating system developed as a free and open source software. There are a number of different flavors and distributions. If you ever hear someone talking about different flavors of Linux, they're just referring to different types of their distributions. They all have slightly different software stacks built in and slightly different ways of managing them. Some examples of them are Debian, Fedora, Ubuntu, CentOS, Red Hat, Arch, Manjaro, Linux Mint, and more. Unlike Windows, the graphical interface isn't deeply linked to the OS. You can choose your desktop environment and trash them whenever you don't want them and pick something else that's going to suit your needs a little bit better. Linux is very popular in academia because it is free and open for development. It's also very popular in enterprise level environments because it's cheap to manage, there's a lot of support for it, and there's a lot of different collaboration with it. So the Unix philosophy originally came from Ken Thompson as a set of standards for software design in a Unix or Unix-like environment. He made each program do one thing well. To do a new job, he would write a new program rather than adding to an old one. Wouldn't expect output from every program to act as input to one another later. It avoid cluttered output, rigid input, and don't require interactive input. It would also write programs to handle text streams instead of binary codes. There's a couple different user interfaces. The first is going to be a graphical user interface, or GUI. You'll often hear that called a GUI, or GUI, or desktop environment. It works much like Windows or Mac desktops you're used to, and often provides comparable interfaces with similar idioms, things like start menu, taskbar, and others. Typically not one monolithic program, but instead a collection of smaller graphical programs all work together. There's also the command line interface, or the terminal, such as Bash, Z Shell, Corn Shell, and others. This is going to be the bread and butter for a system administrator. Although there is a steep learning curve to it, it offers much more granular and powerful access to the system. It's often a lot faster, too, when you're pretty good with it. But don't be afraid or intimidated by it. There are some built-in helpers like man or man pages, apropos, or the common -- help flag. You can even use it on a graphical environment or terminal emulators. To do this, you simply right-click on your desktop background and click Open Terminal. Here's a couple examples of what we just discussed. So it's going to be a typical desktop environment. You have your folders and directories. Here's going to be your command line and terminal emulator. A couple different pictures here, shared network folders and SSH connection. Hopefully I'll get to show you guys a little bit later what those desktop environments look like. If not, we'll cover it later in the courses. Let's go ahead and talk about the system components of a Linux operating system. There are primarily three components. First off is going to be your kernel. The kernel is the core part of Linux that is responsible for all major activities of the operating system. It consists of various modules and interacts directly with the underlying hardware. The Linux kernel provides the required abstraction to hide low-level hardware details of the system or application programs. You also have your system library. System libraries are special functions or programs whose purpose is to tell which program or system utility should access the kernel's features. These libraries implement most of the functionalities of the operating system and do not require the kernel's privileges, instead asking it whenever necessary. And then finally, you have your system utilities. System utility programs are responsible for specialized individual tasks. Here's a visual representation of what we just discussed. At your base level, you're going to have your hardware. And then you're going to have your kernel above that interacting with the hardware. And then above that, you're going to have your shell that interacts with the kernel. And then even your hardware below that. And then outside of that is everything else interacting with the shell, such as cd command, grep command, date, input, output, compilers, things like that. You also have a little bit of a different visual representation here. So you got your hardware, CPU, RAM, input, output. You got your kernel and kernel modules interacting with that hardware. And you have your system libraries and everything else. Here's a quick example of what the terminal is going to look like. So commands you input into the terminal is going to interact with the shell. That's how you get things done on the Linux system. Three common Linux commands are pwd, ls, and cd. pwd stands for print working directory, and this identifies the current path or directory you're at. So unlike Windows, where you have a nice visual representation of where you're at on your system, Linux doesn't do this. So to see where you're kind of at in the tree and file system, you have to type in print working directory. This simply output where you're at. You also have your ls command, or list. The ls command lists the files and folders in the current directory. And then you have your cd command, or change directory. This moves to the defined path depending on what you input to it. A couple different tricks with cd. You can do cd space ... and this will take you back a directory. Or you can even do cd space ... / ... and this will take you back to. You can even do this 2, 3, or 4 times. Let's go ahead and talk about the installation and setup of our lab environment for these courses. There's a variety of Linux OS distributions you can use, each of which may have its own installation and setup. For this class, we recommend installing and using Ubuntu. So there's two ways you can install it. First off, it's going to be natively or directly onto your hard drive. I do not recommend this because if you're unfamiliar with how Linux works and how to install this program, it can actually really mess up your laptop. So we have another way to do it, which is going to be installing on a virtual machine. This is a great way to learn the OS so that you're not actually messing up anything on your laptop. It's simply a simulated computer that you run within your normal OS. And we're going to be using VirtualBox as our virtual machine or hypervisor. So let me go ahead and pull up VirtualBox here. So actually, let me show you where to get these first. Let me pull up my web browser here. If you go to ubuntu.com/download/desktop and click on download, that's going to get you your ISO image for Ubuntu. And then if you go to virtualbox.org, scroll down to the middle of the page, You're going to see a big blue button that says VirtualBox 6.1. Go ahead and click that button, download VirtualBox. Alright, back to our VirtualBox homepage manager. So we got a clean slate here. I'm going to go ahead and click New. It's going to bring up another screen, and let me bring up that other screen for you so you can kind of follow along. Perfect. Let me center that for you and see everything that's going on. There we go. Shrink it a little bit so you can see all the different buttons here. Alright, perfect. So I'm going to go ahead and name this machine Ubuntu. U-B-U-N-T-U. And if you got some time, I would look up the meaning of Ubuntu. It's a fair description of what Linux stands for. And you'll notice it even picked up here what type of machine I'm going to be using. In case it doesn't, we can hit this drop-down button. You can see all the different Linux flavors we can use. We're going to go ahead and use Ubuntu 64-bit. We're going to click Next. Here it's asking you how much RAM you want to allocate to your system. I like to double it to put 2 gigs of RAM. Keep in mind how much RAM you actually have on your computer. You don't want to add too much, otherwise it's going to bog down your whole system. 2 isn't too much, so you should be fine with that. Next, it's going to ask what kind of hard disk you want to use. We'll just go ahead and stick with the default. Create a virtual hard disk now. Hit Create. We're going to stick with the default again, VDI, Virtual Box Disk Image. Click Next. It's asking whether you want to dynamically allocate or create a fixed size physical hard disk. We'll stick with the default here, and you can see the definitions of each on the screen. Click Next. And here it's asking how much storage you want to put on this machine in your hard disk. I would not go below 10 gigs. That's a minimum recommended. If you want to add more, you can. For our purposes, this should be enough right now. Later on, if you decide you want some more storage, you can always come back to the manager and add more storage or another disk. We're going to go ahead and click Create, and voila! We have a brand new machine created. Not quite functional yet. We're going to go ahead and double click on that. It's going to bring up another screen. Pull up that other screen for you here. Maybe, there we go. Okay. So you can see our other screen here. Okay, enlarge this a little bit so you guys get a little bit better look. Okay. So here, it's going to ask you what image you want to use. You can see here it's already filled it out for me because this is where I have it saved. In case you need to go browse to where you actually have it saved, you just click on this little drop down here and browse for it. But we're going to go ahead and use that. I'm going to go ahead and click Start. You can see here it's starting up that menu. Fix the screen for you guys a little bit. There we go. So it's booting up for me. See, it's loading. This process here doesn't take too long. Fix this screen up a little bit better for you. You can see the full output. There we go. Just let it boot up here. It does take a minute. There we go. So we're starting to see our desktop here. Actually pretty cool looking desktop. And once we get to here, it's going to ask what type of language you want. Depending on what type of language you want to pick it in, we're going to go ahead and go with English. We'll go ahead and click Install Ubuntu. And we're going to stick with the English keyboard setup. So we'll go ahead and stick with the defaults there. Hit Continue. And we're going to go ahead and do a normal installation. If we do minimal, we're not going to have a desktop. For this class, we do want to go ahead and install the desktop version of it. So we'll stick with normal installation. And we can go ahead and do download updates while installing Ubuntu. That's fine. We'll go ahead and click Continue. And on this next screen, once it pops up here, going to ask us for a little bit more information.
Thanks for watching. Feel free to add your questions as comments down below.
There we go. So you're going to see here, you see this big red warning sign. This will delete all your programs, documents, photos, music, and others on your operating system. Don't worry about this, guys. We're on a virtual machine, so no need to freak out or get worried. So we're on a virtual machine now. It's simply just saying, hey, I don't see an OS. Can I go ahead and erase everything and install this Ubuntu OS on your system? And since we're on a virtual machine here, it's not your actual laptop or computer, so no need to worry. So go ahead and click Install Now. And it's going to ask you to write the changes to the disk. We're going to go ahead and say, yes, continue. Please do that for me. It's going to ask you what time zone you're in. Depending where you're at, you can click all these different time zones here. So I actually do live in the Midwest here. So I'm going to go ahead and click on Chicago. Hit continue so that my clock is actually accurate for where I'm at. And it's going to ask me for my name, Kevin Downs. It's going to fill some info out for me. It's going to go ahead and fill out the username for me. You can change that if you want a different username. I'm going to go ahead and type in my password. Make sure you write down this password. If you forget it, no big deal. You can blow up your machine and create a whole new one with a whole different name and username and password. But that's going to take some time, as you see, so it's better to just go ahead and write down your password and remember it. We'll hit continue from here to actually start downloading the files for us. Actually, let me bring the screen up a little bit higher so you can see that. So as you can see, it's copying those files. So this is going to take a minute. Hopefully this doesn't take too long so I can demonstrate some commands in the desktop a little bit for you guys. Actually, while that's gone, I'm going to bring up our PowerPoint again and just kind of summarize some things we went over today. So we looked at the Unix philosophy, we looked at the different interfaces, we also looked at a couple basic terminal commands which I can demonstrate you here if this finishes this installing. And we also have an installation guide and a supplementary video. In the next session, we're going to go over some basic user commands, logging in and out, command line editing, navigating the file system, viewing and copying files, as well as controlling the terminal. Let's go ahead and check on our progress here again. There we go. Alright, looks like we're almost done. So close, yet so far away. Shouldn't take too much longer though. This is actually the end of the installation process, so it should be finishing up here soon. Ah, it fooled us. Another loading bar. That's okay. Not too long of a process. While the rest of that's loading, I'm going to take this chance to remind you guys and inform you that if you guys do need a little bit of extra help with any of these sessions or classes, we do have private tutoring sessions. Let me pull up our PowerPoint here because those will be linked. So we do have private tutoring sessions for system administrators. We have weekly and monthly plans. There's also some private tutoring sessions for Linux and Bash scripting if that's something that interests you. Feel free to check any of our other courses out at codingbootcamps.com. Let's go and check our progress here again. We're getting close here. So right now we're getting towards the end of our installation process. If you stuck with me this far into the video, I encourage you to go ahead and speed up the video and skip to the end so we can get to the good stuff on the actual machine itself. Or if you just like to watch the loading bar scroll at normal speed, then go ahead and feel free to stick around. Perfect, so we've reached the end of our installation process. We're going to go ahead and click Restart Now. We'll restart our virtual machine here. It's going to boot back up. It's going to ask you to remove the installation medium and then click Enter. We're just going to go ahead and click Enter. It's going to restart our virtual machine. It's going to boot up Ubuntu. And there we are, beautiful. So we have our machine set up. You can see my user here. Type in my username and log in. We're going to see our desktop for the first time here in all its glory. Well worth the wait. Or maybe not. Because everyone has their own opinion. Here we go, we can go ahead and skip this part. We can click next on a live patch. No, don't send system info. Don't turn on your location services, and click done. So here we are, we have our desktop. As we talked about in those slides, I can click, right click on the desktop and click open terminal. You can see our terminal here. I'm going to go ahead and blow it up for a little bit so you can kind of get a little bit better view of what I'm doing. So we talked about some of those commands. So we can see here if I click in PWD, it's going to say you're at home, Kevin, and desktop, so I'm on my desktop. If I click CD, it's going to take me all the way back and type in PWD again to show I'm just at home, Kevin. So I'm going to go ahead and do ls, list some files here. You can see desktop, documents, downloads, music, etc., etc. If I do CD, downloads, and actually let me show you something here. Everything in Linux is case sensitive, so if I do downloads, CD downloads, it's going to say, hey, I don't know what that is. So I go do CD downloads with a capital D. And we're back at downloads, and I can list everything there. Oops, that is not the right command. Oops. So do ls here. You see I actually don't have anything in my downloads directory. Alright, that's about all I can show you for today, guys. I think that's enough. Thank you for coming to the first session of Introduction to Linux OS, and I hope to see you in the next session. Hey guys, welcome back to our second session of Introduction to Linux OS. My name is Kevin Downs, and I'm happy to be instructing you again. So in the second session here, we're going to go over basic user commands. Before we do that, let's go ahead and recap some of the things we learned in our first session. First things we went over was Introduction to UNIX, Design Philosophy, System Components, the Shell and Command Entry, and then Installation and Setup. In this session, we're going to go over basic user commands, logging in and logging out, command line editing, navigating the file system, viewing and copying files, and lastly, controlling the terminal. Let's go ahead and hop right in here. First thing we're going to go over is logging in and logging out of our Ubuntu machine on VirtualBox. So when you first start up Ubuntu, after installing it, you should see a login screen that looks like this. Let me go ahead and pull up my machine here. So you'll see here, I have my machine booted up. I have my username here. And if I click on that, it's going to open a text box. It's going to have me input my password. So I'll go ahead and do that. I'll hit enter, and it's going to log me into that machine. So that's how you log into your machine. Let's go ahead and talk about logging out of our machine. So once the machine boots up, you're going to see some options here. You'll see log out, suspend, and power off. Log out will actually log you out of the machine. Suspend is going to put your machine to sleep or hibernate it. And power off is going to actually turn off your machine. So keep in mind, if you click that button, it's going to turn off the whole machine, and if you want to use it again, you're actually going to have to boot it back up. So let's go ahead and check those options out. So you see here, the desktop's loaded up. I'll go to the top right corner here. You'll see a little tree icon, speaker, battery, and a little down arrow. We're going to click that button. And on here, you're going to see power off and log out. We're going to click on that, and then we'll see our options below. Log out, suspend, and power off. We're going to go ahead and click log out and log out of our machine. We're going to see another menu. It's going to ask us to confirm that we want to log out. I'll go ahead and click log out. And there you go. We're back to our screen here asking us to log into a user. Let's go ahead and talk about navigating the file system. So Linux file system will be unfamiliar to Windows users, but Mac users may recognize it. Look around using the built-in file manager to kind of familiarize yourself with the structure. How it kind of works is the files are held in a tree structure with a root denoted by the path /. Each directory under will be preceded with a / and followed by a / to denote the beginning of the next directory. So let's go ahead and check that out on our VirtualBox here. So you see here, I went ahead and typed in pwd, if you remember from my last session, to show where I'm at currently. So you'll see a /home/Kevin. Okay? So that first slash here denotes the very root or beginning of all these files and directories. And then next you'll see home, okay? And then you'll see another slash, okay? So this slash here is saying this is the root or beginning of Kevin, okay? But it is the end of the home directory, okay? Let's go back to our PowerPoint here. Keep in mind that all files and commands in Linux are case sensitive. So if you type in a command or directory, lowercase when it should be uppercase, it's not going to recognize that command or directory or file. So keep that in mind and be very careful when you're typing things in. Directories are separated in path using the / character or the root. Okay? Don't confuse this root with the root user. Okay? This is simply just stating that this is the beginning. Okay? There's different types of files. You have ordinary files, which can contain text files, data files, command text files or scripts, and executable files. You also have directories, and then you're going to have links. Links are used because rather than having multiple copies of a file, Linux uses linking to one file to save disk space. Okay, so I can have a file on one.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
Location, and I can link it to a file in another location, and this way I don't have to actually create another file elsewhere. It will just link back to that original location. Typically there's going to be two types of links. There's going to be a hard link and soft link. However, we're not going to focus on that right now. That's not something we need to worry about. This slide here just gives a different visual representation of how it works. So see here we have the root of this file system, or /, and then underneath that we can have different files or directories. So bin, dev, etc or etc, home, tmp or temp, and usr. Don't confuse this as user. This actually stands for Unix Shared Resources. Okay? And underneath that we can have more files or directories. So if we were to look at this in the actual machine, you would actually see a slash in between maybe home and Patrick. So it would look like /home/Patrick/school. Okay? Linux is fundamentally a multi-user system. There's going to be multiple people using a Linux system. Every user on a Linux system is given a sectioned off part of the file system that belongs to them, their home, if you will. For a user named Tom, their home directory exists as /home/Tom. Okay? Whenever a little squiggly sign here appears, this is called a tilde. At the beginning of a file's path, this is shorthand for my home directory. Okay? So when Tom uses the tilde, it means /home/Tom, or if Fred uses the tilde sign, it means /home/Fred. Okay? So let me go ahead and demo that for you real quick. So we can see here I got my terminal pulled up here. Okay? So if I do pwd to show where I'm at right now, you see /home/Kevin. Okay? And if I were to navigate somewhere else, /desktop, okay, you can see I'm in a different location here, /home/Kevin/desktop. If I were to just type in cd and that squiggly sign or tilde, it's going to take me back to /home/Kevin, okay. Just to prove that to you, I'll type in pwd again, and you can see it takes me back to /home/Kevin, okay. So that's just a shorthand way of typing out your home directory and so that you don't have to type everything out. Let's go back to our PowerPoint here. So during this course, you're going to be using the terminal emulator to do a lot of your work, okay? On your desktop, to pull up the terminal emulator, you're going to right-click and use the Open in Terminal option. Or, if you want, you can just type Control-Alt-T to open one at any time, okay? The window opens is called a terminal emulator. It behaves like the terminal that exists underneath the graphical interface or Ubuntu. Okay? Keep in mind this is not the true command line or terminal, it's just an emulator. So if I go to my desktop here, you see me do it a couple times. I'm going to show you one more time in case you didn't catch it. So I'm on my desktop here. I'm right-clicking on my mouse. This option opens up and I click Open in Terminal, and it's opening up that emulator for you. Okay, and from here we can start typing in commands and using the emulator. Alright, let's go ahead and go over some basic user commands here. You'll see here we have a list of common commands listed. First one's going to be echo. This will display our print text to the screen. We have exit, which will close the terminal. Clear, which will clear all text in the terminal. Make directory, or mkdir, make a new directory. rm, or remove, which will remove and delete a file. mv, or move, which moves files. cp, or copy, which copies files. ps, which will list all active user programs and display a PID, or PID, which is a process identification number. We have top, which shows an interactive list of current processes running. We have kill, which will kill or stop the process with a listed PID number. And then we have man, or manual, which will display the manual for the listed command. We also have cat, which will display the contents of file, also used to combine or concatenate multiple files. And you'll see here in this word, concatenate, that's where cat comes from, C-A-T, okay? And then next we have vim, which will open a file terminal-based text editor, okay? Vim stands for VI improved. And then the last one we have is chmod, okay? And this will change or set permissions to a file defined by the flag that you give it. And we'll go in later discussion in later sessions about permissions and files and all that, okay? Let's go ahead and demo some of these commands here. So we're going to open our VirtualBox. Go ahead and open it with me. And first one here, we're just going to test out echo. So to use the echo command, we do E-C-H-O. Oops. There we go. E-C-H-O space, double quotation mark. And then I'm just going to type in hello. And then end it with double quotation mark. Now hit enter. And you see it just prints out the text to the screen, okay? So anything you put inside of these double quotation marks, it's going to print out to our screen here, which can be helpful for putting things into files. Next is exit, so E-X-I-T. This will close our terminal. Go ahead and open the terminal back up. And the next one we have here is clear. So if you have a lot of commands on the screen, you want to free up some space, and just type in random stuff here so we can get some space on our screen. So if I type the clear command, it's going to clear our screen and give us some space back. Okay. Another helpful thing we can do, kind of a shorthand version of that, is I can do Control-L, and it'll also clear the screen for us. Next we have is mkdir, or make directory. So I'm going to show you here. I'm going to do an ls, and you'll see all of our directories here listed in blue. Okay. So I'm going to do a mkdir, and then space, and then testdir. So I'm going to make a directory called test directory. I'll do that, and I'm going to do another ls, and you'll see now that I have a directory called test directory here. Okay. So the next one we have here is remove. Okay. So we can remove files. So I'm going to create a file real quick called test. Okay. I'm going to remove that file. So let me go ahead and do an ls. You see there test file is created here. So I'm going to remove it now. So rm space test. And you'll see that that test file is gone now. Okay. Let me go ahead and clear the screen. Alright, next command is going to be move. So let me go ahead and list our files here. I'm going to make a test file again. So you see test file there. And what I'm going to actually do is I'm going to move this test file into testdir. Okay? So you do mv, and then you're going to type in the file that you'd like to move, which is going to be test. And then you're going to type in the location you'd like it to move to, testdir. Oops. There we go, testdir. You'll notice here that it's preceded by a slash because we're actually going to put this file underneath of testdir. Okay, so I'll do that. We're going to go ahead and change directory cd to testdir just so we can see that that file got moved there. Do an ls to list the files in this directory, and you'll see that test was moved there. Now if we go back one, cd ... you'll notice that test is no longer in the previous directory, so it did actually move the file. This is also a handy way to rename the file. Okay, so if I do cd testdir again, we'll see we have test there, and I want to rename that file. I can do mv, the file you want to rename, test. I'm just going to name it test2. Okay, I'll do an ls, and you actually see that the file is renamed now. Okay. So move is helpful if you want to move a file to a different location, or if you'd like to rename a file. All that's doing is it's just telling the system that this file resides in a different location now, or that has a different name now. Okay? So let's go ahead and go back here. Clear my screen. Next command we have is cp. Okay, so I'm going to make another file. I'm just going to call it test. So you see now we have that test file here. I'm going to copy test, so we do cp space, the file we want to copy, and where we want to copy it to. So I'm going to do testdir, again that slash, because we want to put it underneath there. I'm going to hit enter, and then I'm going to change directory cd to test directory. Okay, I'm going to do an ls, and you'll see that test2 is now, or I'm sorry, test is now in that directory. Now if I go back a directory, you also see that test is also still inside of this previous directory, okay? So the copy command is actually creating another copy of the file. It's going to exist in its original location as well as the new location it's in. So the ps command, when we run that, we can see here it shows all the current processes running. All right. In this case, I just have the bash process running, which is this terminal. And then we also have the ps command, which is the command that we just ran. Okay. Another interactive way of listing processes running is the top command. So you see here on top, it has a live feed of all the processes running. Okay, so this is a real-time look at how your system is running. All right. So this is useful if you want to see what things are taking up CPU or RAM and things like that. To get out of this, we just hit Q for quit. You'll notice when I do that, though, that the top command is still displaying it. It's just not real time anymore. So we're going to go ahead and clear our screen to get rid of that. Next command would be kill. So K-I-L-L. And then you would type in the process ID. All right, let's go ahead and do an example of that. I'm just going to run a process here. Sleep 60. I'm going to put that in the background. Okay. I'm going to do PS to list the processes running. And now you'll see that sleep command there, okay? So in this first column is where it shows the process ID of columns, or of processes. That second column is the terminal it's running on. And then in the last column here, it tells you the command. So I'm going to do kill. And then the process ID, 3224 of sleep. And then it kills the command, okay? Next command we have is man, or manual pages. So I can do man kill. And you'll see it actually brings up a really helpful manual page for this command kill. On here you can find tons of info on it. If you want to scroll down on there, you can use your arrow pads and it'll scroll one line at a time, or if you want to scroll a whole page at a time, you hit your space bar. Okay? Another helpful thing to use in here is if you use the / button. Let me actually move my screen up here so you can see. So you see I do a / and I can actually type in words and it'll search the document for me. Okay, so maybe I do example, and remember everything is case sensitive in Linux, so I do capital E. It says pattern not found. Let's see if I can do lowercase. There we go. Now it brings up examples here. So examples of how to use this command. Okay, and again, to get out of this, we just type Q for quit. Alright, next command we have here is going to be cat. So if I do cat, actually let's look at our files here. So I have test, let me put some words in there. Oh, I need to do echo. There we go. Okay, let me clear my screen real quick. Alright, so we have our files here. I'm going to see what's inside of this test file here. Okay, so I'm going to cat it, C-A-T space T-E-S-T. And you'll see there it just says words. So that's all that's contained in this file right now. Okay. Next command we have is vim. And this is how you actually open files and edit them. Okay. So unlike in Microsoft where you can just click on a file and go to maybe Word or Excel and start editing them, in Linux we have to use vim. Okay. So to use vim, we do vim, and then I go to the file, T-E-S-T, the file I want to edit, and I hit enter. Okay. Now for some of you, when you try this, it might not work. Instead, you might have to just use VI because it might not be installed on your machine yet. So let me go ahead and do that. So just do VI. If vim doesn't work, do VI in that file you want to edit. So you can see it's very similar. Vim just has some more functions to it. Okay. So to exit out of this, you're going to hit escape. So put you into command mode, and then you'll do colon. Let me move my screen up here so you can see. So do escape, colon, and you can do Q for quit. Okay? And it'll take you out of that program. The last one we have here is chmod, C-H-M-O-D. Okay? And then in here you can do different permissions on files. So we'll use, just an example, maybe user plus, and I want to give it execute permission, so plus execute, and I'm going to do that on the test file. Okay, now we'll change permissions on it. For right now, don't worry too much about permissions. We're going to go into much more detail later.
Thanks for watching. Please like and share this video.
About how to use this command as well as others, but I did want to demo it for you real quick. Let's go and go back to our PowerPoint here. Alright, so the terminal holds a history of all commands that are used in the current session or the instance of the terminal. You can look back and forth in this history using the up and down arrow keys. Similarly, you can move your cursor back and forth in your current line using the left and right arrow keys. If your cursor is overlapping a character, typing will put the new character immediately before the overlapped one. Okay? So if we look at this table here, it just kind of summarizes that. So I can hit the up arrow or Control P, which will recall the previously used command. I can hit the down arrow or Control N, and it recalls the next command. I can hit left arrow or Control B to move left on my line. I can use the right arrow or Control F to move forward on the line. I can click the home button or Control A, which will move the cursor to the beginning of the line, or I can hit Control E or N, which will move my cursor to the end of the line. So let me go ahead and pull up my virtual box here again. Show you a quick example of that. So this is actually really handy and will save you a lot of time when you're messing with these commands. So let's say I have a really long line of things, okay? And I don't want to use my arrow keys to go all the way back. I can press left on my arrow key and it will go one line at a time. Or I can press right and it will go right to one at a time. Or I can do Control A and it takes me all the way back to that line. Similarly, I can do Control E and it takes me all the way to the end of that line. So that's much quicker than trying to arrow left or right on it, okay? So if I press S up on my arrow pad, you'll see it brings up that last command I used, which was chmod u+x test. If I press down, you'll see it brings back up my command that I just tried to type in. Now, this isn't actually command, obviously. This is just me typing in some example stuff. Okay? Let's go and go back to our PowerPoint. So a command you guys have seen me use a lot is the list command, or ls. So to list the files and directories stored in the current directory, use the following command, ls. But this command also supports an ls-l option, okay? Anytime you see a -l or a dash something, that's a flag on a command. So flags alter how the command actually sends its output to you. And the flags add a lot of functionality and a lot of options to what you can do with the commands. So I'm going to go back to my terminal here. Oops. So I can do an ls-l, which stands for long listing. You'll see it lists a lot more info as opposed to just doing ls, okay? I can also do a shorthand version of that, ll, and it'll list everything as well, okay? So when I do an ls-l, what's usually listing here is info about the file. So in this first column, we have the permissions. In the second column, we have the user owner of the file. In the third column, or the fourth column, we have the group owner of the file. In this fifth one, we have the size of the file in bytes. In the next column here, we have when it was last edited. And then the final column actually shows the name of the file. Okay? So on this next slide, we're going to talk about meta characters. Meta characters have a special meaning in Unix. For example, the star sign and the question mark are meta characters. So we have an example of it here. We have ls space ch star dot doc. This will display all the files, the names of which start with ch and end with the .doc. So depending on where that star is, depends on how that's going to search for it. Okay. So let's show a quick example of that. So I'm going to list the files I have here. Let's say I do an ls, and I do a star, and everything that's, let's say, ends with an s. So documents, downloads, pictures, templates, and videos, okay? Let's go and clear our screen, do an ls. So let's say I want to find everything that actually starts with a capital D. So I'll do ls, capital D, and star. And again, it'll display desktop, documents, downloads, okay? So depending on where that star is, depends on how it does that output. Anything before the star means everything that starts with that. Anything behind the star means anything that ends with that, okay? So that's very helpful when you're trying to find something or trying to filter your results. You can also use that for creating different files within other files, but don't worry too much right now about meta characters. Just understand that they do exist and that they can be very helpful. Alright, as far as creating files go, you can use the touch command, which you guys saw me use. This creates an empty file with a given name. For example, I can do touch file name and it'll create an empty file named file name. You can also use the Vim editor to edit text files in any UNIX system. So if I were to use Vim and then a file name and that file didn't already exist, it would open a file for me and it would be empty and I can start editing it, okay? However, if I just use touch, it's just going to create that empty file and it won't start editing it. Alright, copying files. To make a copy of a file, use the cp command. The basic syntax of the command is copy, source file, and destination file. Okay, so we saw an example of that earlier. So let's say if we do a copy file name to copy file, it's going to copy the file name to copy file. And as we discussed earlier, the move command actually renames files. So to change the name of a file, use the move command. And the following is the basic syntax. So you do mv move space old file space new file. So you're putting the file you want to rename and then the location or what you want to rename it to following that. So if we do an mv space file name slash space new file, it's going to take file name, the file name, and it's going to rename it new file, okay? Or it'll move it to the new file location. Alright, let's talk about controlling the terminal. So while the terminal program is running, you can send it various signals using the keyboard. Some example of this is Control-C, which is signal interrupt, or the interrupt signal. Usually this causes the program to abort, but may simply stop some programs. There's also Control-Z, which is signal stop or suspend signal. Again, this usually causes the program to abort, but may simply stop until they get a signal to resume, like say continue. There's also Control-D, or end of file character, and this is used for when a program wants a full file to input, but you tend to type it in. So let's go ahead and do some quick examples of that. Clear my screen here. So I'm going to do that sleep 60 command again, except this time I'm not going to put it in the background. So you'll see here I don't have control of the screen anymore. I can type things in, I can press LS, I can press top. It's not going to work because that sleep 60 has put the terminal to sleep, okay? So if I want to stop this program, I'll do Control C on my keyboard, and then I get my prompt back, okay? So I'm going to do it again. This time I'm going to do it with Control Z. You see I can't do anything. It's not letting me get control of the terminal. So I do Control Z, and you'll see that it suspends the program and even tells you that the command is stopped there, okay? So if your terminal ever locks up or you have a process that won't free up, you can always try these commands and it'll give you control back. Okay, so in summary, you've learned about basic user commands. We've also seen how to log in and out of your Ubuntu machine. We also learned about terminal emulators, and we have seen how to navigate the file systems. We have also learned about how viewing and copying files are done, and then we have seen how to manipulate the terminal. In our next session, we're going to go over types of editors such as Nano, VI, and Vim, basic editor tasks with Vim. We're also going to look at how to edit multiple files, name buffers, and we're going to look at how to start up a Vim file. Guys, if you're struggling with any of these concepts or you need a little bit of extra help, please click on this link. We have weekly and monthly plans available for private tutoring sessions for system administrator management. And we also have some Linux and Bash scripting private tutoring sessions. Thanks so much for joining me. I really hope to see you in the next session. I hope you guys had a little bit of fun being able to actually use some commands in that terminal and see what you can do on the machine. Hey guys, welcome back to Introduction to Linux OS. This is going to be session 3 of the series. Again, I'm Kevin Downs, and I'm very excited to have you back with us. So let's go ahead and get started here. We're going to be covering text editing for this session. Just a quick recap. Last session we went over some basic user commands, logging in and logging out of our machine, command line editing, navigating the file system, viewing and copying files, as well as controlling the terminal. Today we're going to be covering types of editors, such as ed, ex, and vim, some basic editor tasks with vim, editing multiple files, named buffers, and the vim startup file. So let's go ahead and talk about some of the editors we have here. First we have ed or ed, which is a line editor for the UNIX operating system. It was one of the first parts of the UNIX operating system that was developed in August 1969. Elvis is a VI-EX clone. It closely resembles the UNIX text editor VI, but adds quite a few commands and features. Elvis is written by Steve Kirkendall and is distributed under the Clarified Artistic License, which is used by Perl, and is a GPL-compatible free software license. And GPL just stands for GNU or GNU Public License, and this just states that everything is free and open source. Editing files using the screen-oriented text editor like VI is very popular. And because of this, we're going to pretty much focus on just VI and Vim in this class. An improved version of VI editor, which is called Vim, VIM, which is available now. It stands for VI Improved, okay, and that's where Vim comes from, VIM. VI is generally considered the de facto standard in Unix editors because it is usually available on all flavors of the Unix system. Its implementations are very similar across the board. It requires very few resources, and it is more user-friendly than other editors such as ed or ex. Nano is a typical text editor for Debian, a Linux distribution, and is mostly used in Debian and FreeBSD systems. VI is the first version of the editor, which was introduced in Fedora 6. Later, it was implemented on CentOS and Red Hat, which are Fedora-based Linux distributions. Vim is the second most advanced version of VI, which is introduced in Fedora 12 and later introduced in CentOS 6 and Red Hat 6 in the later versions. For this class, we're going to need to manually install Vim to use it. I will demonstrate how to manually install Vim on your Ubuntu system. And we're going to learn how to create a file using Vim. We're also going to learn about the copy-paste function with Vim editor in shell. And we're going to learn how to exit from Vim and how to save files in Vim or to search any specific word via Vim and many shortcuts and tricks of Vim. Alright, so editing multiple files in Vim. First of all, in Vim you can enter colon and then help. That's going to bring up a lot of helpful topics, including a short tutorial. So let me go ahead and hop on over to our machine here. Exit out of this. Okay, so first things first, we need to go ahead and install Vim. Okay, so to do that, we're going to have to type in sudo. Okay, and this is just going to elevate some privileges for us, and we'll talk about later what sudo stands for. And then we're going to type in apt. Okay, and then we're going to type in install, and then Vim, VIM, and we're going to hit enter. Okay, so you're going to see it went through some processes for us here, and now Vim is installed on our machine. Okay, let me scroll up for you so you saw all that download, and now Vim is installed. Okay. Let me clear my screen here, get some space back. So if I go into Vim, let's just type in Vim test, and I type in escape, so I hit escape on my keyboard, and then colon, and then help. I type in help, and you'll see it at the bottom here. Let me shorten my screen here so you can see the full thing. There we go. Should be able.
Thanks for watching. Feel free to add your questions as comments down below.
See the full thing now. So I type in colon help and I hit enter. You're going to see it pops up some helpful tutorials for us. and a lot of files. So let's go back to our PowerPoint here. So you see there's a lot of helpful topics of interest. And if you just want to click on any of them, all you have to do is press Control and then right bracket, and that topic will be open. A good place to start with this would be this file here, usr_07.txt. So we go back to our machine here. I'm going to just press down on my arrows. And I'm going to keep going down till I find that USR07 here, which you'll see on my screen. Okay? And then I'm just going to click Control and then right bracket. You'll see it'll open up that file for us here. You see there's more helpful files in here that you can look at. For example, if I want to open this one here, edit another file, I just do Control, right bracket, opens that for us here, and you'll see some helpful info. Okay. So after you start Vim with a list of files, you can move to the next file by entering next or in for short. Now when I do that on my machine, so I gotta hit escape and then colon sign, and then I'll type in next. You'll see it says there's only one file to edit, so there's no other file to move to. You can also go to previous files by typing in previous or W previous. Again, if I type that in, escape, colon, and I do W previous, you see there's going to be only one file to edit, so there's no file to move to. Okay. Now when editing multiple files, if you ever get lost or need to know which file you're actually at, it's helpful to type in colon ARGS, and it'll tell you what file you're currently editing. So I'll type escape on my keyboard, and then colon, and then ARGS, and you'll see in the brackets there it's going to say test as the file I'm currently editing. Okay. So go back to our PowerPoint here. So our next slide, we're going to talk about named buffers. So as you've seen, while I'm editing files, your last deletion is always saved in buffer, okay? So as I'm editing these files, things I delete or change are going to be saved in a buffer. You can access the content of that buffer and put the saved context back to your file with the command put, okay? So yank acts kind of like Control-C if you're familiar with Windows, which is going to be copy. And then P is going to act as paste, or Control-V on Windows. However, in Linux, it works a little bit differently in the file. You have to press Y to copy it, and then you have to press P to paste it. Okay. So if I go to a machine here, let me go ahead and exit out of this. Oops. I'll go to my file here. So on this first word here, example, I'm going to type Y. So I hit Y on my keyboard. And then I'm going to move down one line, and I'm going to press P on my keyboard. Sorry, P, the letter P. And you'll see there, paste the word example in there. Okay, so that's a quick way to copy and paste words in this Vim editor. Let's go back to our PowerPoint here. You can use the colon file new name to change the buffer name. For example, you can change it from help to file or F. And you can set the current file name to name. The optional exclamation point or bang, anytime you hear someone use the expression bang in Linux, they're talking about the exclamation point. This avoids truncating the message as with file. If the buffer did have a name, the name becomes the alternate file name. An unlisted buffer is created to hold the old name. Now, as far as this part goes, guys, I wouldn't worry too much about this. This isn't something that's commonly used, so from here down, changing the buffer names, typically this isn't something that you're going to be using too often when you're using Vim. Instead, I would focus more on the yank option here. as well as the P option here. You also see here that we have our deletion. So if I type in D, it's going to delete a line. So if we go back to my virtual box here, and I want to delete that second example I put in, I just hit DD twice, and you'll see the line gets deleted. Okay. Let's go back to our PowerPoint and move to the next slide here. So Vim startup file. So most often Vim is started to edit a single file. Typically you're not going to be editing multiple files in Vim. Instead you're going to be editing one file at a time. More generally, Vim is started with Vim and then option and then file name. Okay. Option arguments and file name arguments can be mixed, and any number of them can be given. However, watch out for options that take an argument so that you're not getting mixed up here, you're not confusing Vim here. For compatibility with various VI versions, see command line arguments. So to start editing the file using Vim, type in Vim and the file name, and this will open the file to edit for you. Once this is open, you can begin editing the file. Once in the file, you need to enter insert mode by clicking the letter I on your keyboard. To save the changes you have made, you will need to click escape on your keyboard, and this will get you back into command mode, and you can type WQ, which means write, and quit, and this will save any editing you've done to the file. If you want to exit without making any changes to the file, you'll need to click escape to get back into command mode, and then colon and Q, as well as the exclamation point or bang. Okay, so let's go ahead and check that out on our virtual box here. So I want you guys to follow along with me here, wherever you're at. Oops. Escape. So wherever you're at here, I just want you to type in CD. It's going to take you all the way back home. And I just want you to type in VIM space. You're just going to type in test. Okay? You'll see it opens up a file for you here. Mine already happens to have in it just because the file test already existed and I already had some content in it. I'm going to go ahead and delete that line so we have a fresh slate here. So if I want to type something in here, all I have to do is press I on my keyboard. You'll see now at the bottom left corner of the screen, you'll see the word insert here. Okay, this is how you know you're actually in insert mode. You can actually start typing and editing a file. So I want to add some words here, so I'm going to add some words in my file. Okay, and I want to actually go ahead and write this file, save it, if you will. Okay, so I have to press escape. So I'm going to hit escape on my keyboard. Now I'm in command mode on Vim. Okay, and you'll notice insert disappeared here at the bottom. Now to actually type in the commands, I have to hit colon on my keyboard. So shift and then colon. And then I'll type in the letter W for write and then Q for quit. Now go ahead and type in CAT space test, and you'll see the contents of the that file you just created. Okay. Now to go back and edit that file, I'm going to type in Vim space test again. You see we're back at our file. I'm going to go ahead and delete that. I'm going to press escape. And this time I'm just going to try and quit out. Okay. Now you're going to see when I try to quit and I've made changes, it says no write since last change. Okay. So it's telling you you've made changes to the file. We don't want to quit unless you want to save something in that file. If you're saying, hey, I just want to quit anyways and I don't want to save anything, go ahead and escape again. Colon, Q, and then the exclamation point. And this will actually exit the file without making any changes. So I'll hit enter. And again, I'm going to open that file back up, Vim test. And you'll see that our words are still there. Okay, so that Q exclamation point actually exits the file without making any changes to it. Okay, if I wanted to make changes to it, so I want to delete this, I would hit escape, write, quit, and then I go back to that file, and you'll see now those changes I made were saved. Okay, now let's say that I do have some things in here, so I go to insert mode, I hit I say test words. I'll go ahead and save that for now. Open the file again. Now let's say I just want to quit. I haven't made any changes. I hit escape and just the letter Q. and it go ahead and lets me escape and quit out of the file that time because no changes were made to the file. Okay, so that's a very handy thing to know for Vim. So if you're ever editing a file and you make some changes and you're not quite sure what you changed and you just want to exit without making any changes to the file so that's in its original state, you would just hit escape, Q, exclamation point, and you exit the file without making any changes. Let's go ahead and go back to our PowerPoint here. And let's go ahead and summarize some things we've talked about today. So we talked about the types of editors, things such as ed, X, and Vim. We talked about basic editor tasks with Vim. We talked about editing multiple files with Vim, named buffers such as yank, delete, and paste. And we also talked about how to start up a file with Vim. In our next session, we're going to talk about the UNIX process model, process states, monitoring and controlling processes. And as always, if you're having issues or trouble kind of catching on or keeping up with the things we're learning, there's always private tutoring sessions available. Weekly and monthly plans exist, and there's also Linux and Bash scripting private tutoring sessions available. Thank you so much for joining me, guys. I'm looking forward to seeing you again in the next session. Hope you had some fun and learned some things, and I'll see you next time. Hey guys, welcome back, and I'm very excited to have you back with us for our fourth session of Introduction to Linux OS. My name is Kevin Downs, and I'm going to be instructing you today. So today we're going to be going over UNIX processes. In our last session, we went over text editing, types of editors such as ed, ex, and vim. We also went over some basic editor tasks with Vim. We edited multiple files. We went over some named buffers. And we also showed you how to start up a Vim file and edit within that file. Today, we're going to be going over the UNIX process model, process states, and monitoring and controlling processes. The UNIX process model is a simple and powerful abstraction for running server-side programs. It provides a helpful way to think about dividing a web app's workloads and scaling it up over time. Linux uses the process model for a web, worker, and all other types of dynos. So you can see here we have this graph here. So we can get multiple different processes running. We can have web 1, worker 1, clock 1. And on top of that, we can have web 2, worker 2, and above that we can have worker 3 and worker 4. And all this is saying is that we can have multiple processes and jobs running at the same time in Linux. And they can be stacked on top of one another, or they can be running alongside one another. So there's a lot we can do within the UNIX model. So on our next slide here, we're going to look at process states. In a multitasking computer system, processes may occupy a variety of states. These distinct states may not be recognized as such by the operating system kernel. However, they are a useful abstraction for the understanding of processes. So you can see here we have processes that can be running, they can be waiting to run. We can have processes that were blocked. We can have processes that were swapped out and blocked, such as page file and swap space. We can have processes that were swapped out and waiting. We can have processes that were created. And we can even have processes that are terminated. Okay? For right now, we don't have to worry too much about process states. Just be familiar with some of the basic ones, such as terminated, which is going to mean that a process is no longer running. And we're going to have a running state, meaning the process is running. Or we might even have one that's waiting, meaning that the job's ready to go, but it's waiting to run based off of some given circumstances. Okay, so that's going to be the main ones. And be familiar with what kind of memory they're using. So in here, these processes aren't using any memory. These guys were using the main memory. And then on the bottom here, these guys are using some of our backup memory, such as swap space or page file space. Alright, so to manage processes, the operating system tracks processes through a 5-digit ID number known as the PID or PID. This is the process ID. Each process in the system has a unique PID assigned to it. PIDs eventually do repeat because all the possible numbers are used up and the next PID rolls over or starts.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
Over. At any one point, no two processes with the same PID exist in the system, though, because it is the PID that Unisystem uses to track each process. So that's important to know, that at one given point, no two processes are going to have the same PID number. However, a job could end, and later on down the line, its PID number can be used for a different process. For starting a process, when you start one, such as running a command, there are two ways you can run it. You can run it in the foreground, or you can run it in the background. Foreground processes, by default, every process that you start runs in the foreground. It gets its input from the keyboard, so we type in our command, and it sends its output to the screen. So it sends the command output to our screen so that we can look at it and see what it did. An example of foreground processes is the ls command. So ls will list all files in the current directory, as we know. So let me open my VirtualBox here. Let me log in. So I'll type in ls, and I'm going to hit enter, and this is going to run it in the foreground, and you'll see it sends output to the foreground of the terminal here. Okay, so this is how you run a command in foreground. By default, this is what we're going to be doing most of the time. And as you can see here, it says the process runs in the foreground, the output is directed to my screen, and if the ls command wants any input, which it does not, doesn't need any input, it waits for it to run from the keyboard. Okay. While a program is running in the foreground and is time consuming, no other commands can be run, meaning no other processes can be started, because the prompt would not be available until the program finishes processing and comes out. Okay. So on our machine here, we can see this happens pretty quickly. As soon as I type in ls, it runs almost immediately. Okay. But from the time I hit enter to the time that it outputs all of this files here, nothing else can be typed in. Okay. So that's what this PowerPoint's saying. Is saying that while we're running a command in the foreground, nothing else can be run. Okay, so I can show you a quick example of a process that would hold up your terminal. So if I do sleep 60, you're going to see that it doesn't output anything, and I also don't have a prompt anymore. Okay, you can see that this prompt isn't showing up. It will let me type things, okay, but it's not actually going to let me output anything. Okay, you see I type in date or ls, or even pwd, and it's not letting me actually type anything in or any commands in. Okay, so I would have to wait for that command to finish before I could actually type anything in. Okay, and all this command is doing here is telling the terminal to go to sleep for 60 seconds. Okay, so we could wait a minute for it to free up. I'm going to go ahead and stop it now, though. With Control-C, as we learned earlier, we'll stop the process. Okay, the other way to start a command is actually running in the background. A background process runs without being connected to your keyboard. If the background process requires any keyboard input, it waits. The advantage of running a process in the background is that you can run other commands. You don't have to wait until it completes to start another. Okay, so I can actually run multiple commands at a time and not have to wait on one or the other to complete. Just be aware that while you're running multiple processes in the background, that these are using resources such as RAM. So if you have tons of jobs and tons of processes running, this is going to hold up your machine. And if it starts getting slow, you might want to start finishing those jobs or wait for them to finish before you start running others. The simplest way to start a background process is to add an ampersand. Okay, so that's this little symbol here. So you want to add an ampersand at the end of the command. Okay, so if I go back to my machine here, and I go ahead and run ls, oops, so I'm on my machine. Let me clear the screen here so you get a better view. So I do ls, and I put ampersand. It's going to actually run this process in the background. Okay, you see it actually outputs for us, because as you know, ls doesn't actually need any input. Okay, I can also do that with that sleep command you saw just a moment ago. So sleep 60, and I can put ampersand. You'll see that's now actually running in the background, and I don't have to worry about it anymore. Eventually this will time out and tell us that it is finished. So let's go back to our PowerPoint here. Oops. So as you can see here, it says, here is the ls command wants any input, which it does not. It goes into a stop state until we move it into the foreground and give it data from the keyboard. The first line contains information about the background process, the job number, and the process ID. You need to know the job number and manipulate it between the background and the foreground. Press the enter key and you will see the following. So let's go back to our virtual box. So on your machine, you can go ahead and type ls space ampersand, which is going to be above the letter or the number 7. So you just have to hit shift 7 and it'll type in ampersand. It's going to run that in the background. It's going to output ls for us. You'll just hit enter and you'll see this line here. It's going to tell you that that ls command finished. You also see that our sleep 60 command finally did finish. Okay. So you'll see here the job number, which is 2. So sleep 60 was our second job. And then you'll see 3 here, which was that ls command. That was our third job. You also see a little minus sign. This indicates that this is the last job that was run on your system. Okay. And as you can see here, that's what it's explaining. It's saying this first line here tells you that the ls command background process finishes successfully. So it tells you it was the first job in this example and that it finished, and this is the command that was run. On our next slide, it's going to explain in depth a little bit more about this process management and listing running processes. So you can see it's easy to see your own processes by running the command ps, and it will output some info as follows. So if I go to my virtual box here, I type in ps and hit enter. It's going to show you some jobs that I have running. Now as you can see here, it has bash, which again is just our terminal. Okay, so it's this terminal emulator that's running. That sleep command that I had running. Okay, and then also the ps command itself. Okay, so I typed in the ps command, so it's telling you that command was also ran. You'll see in this first column is the PID, or process identification number. Okay, the terminal it was ran on in this middle column here, and then the command itself in this last column. Okay. So along with that ps command, one of the most commonly used flags for ps is the -f command. Okay. Anytime you see the word flags, that means that an option is set on the command itself. So every command is going to have multiple options and flags that you can use with it to actually alter how it runs. Okay, and this is very powerful and useful because you can add some options to your commands to output some more things for you. So in this one particular, it's talking about the -f option, or full, and this will actually provide a little bit more info than just running ps by itself. So we can see here we ran ps. Now if we do ps space -f, we actually get a little bit more info here. So in this first column, it's going to tell you that Kevin was the user that ran the command. Second column is going to tell you the process ID. Okay. Third column is PPID, which is going to be parent process ID, meaning that the original job that ran created this command. Okay. So we have things called child processes. So it is possible that you run a job or a process, and then because of that, another job or process runs and starts. Okay. So if that were to be the case, you would see a parent ID, and then you would also see a child process. Okay. But don't worry about that too much. For now, just recognize the fact that this PPID stands for the parent process ID. Okay. This shows you the start time, and this is in military time. Okay. So this tells you this was started at 10:48 p.m. And then this tells you what the command was here on the last column. Back on our PowerPoint, let's go ahead and go to the next slide here. So we can monitor the process in Linux in many different ways and methods. We just saw one using the ps command. We can also use a command called top, which I talked about in our last session. And this shows you the CPU usage as well as many other processes running. Okay. So let me go ahead and spin up top for you on here. So if I type in the word TOP and I hit enter, and you can go ahead and do that as well on your terminal, it's going to pull up this nice big long list for us. It's going to show you all these different processes running. Okay, if we look at the top here, it shows you the CPU usage percentage. So not a whole lot getting used here. You can even check that out in the middle column here. It shows you what process is running as well as how much the CPU is getting run. Okay. Shows you how much memory is available here, how much swap is available here. Okay. Now another helpful function at the top is I can actually do shift and then type in right arrow, and it will actually sort it by processes that are using up the most memory here. Okay. As well, I can do shift to the left. It's going to shift it and show different processes using the most CPU usage here. So to get out of the top, I can just hit Q for quit. Okay. And again, once you quit out of the top, you'll see that it's no longer a live feed, but that output is still going to stay for you there. Okay. I'm going to go ahead and clear my screen so you can see. So useful things to know about top command is that it just shows you different programs here. It shows you which ones are using CPU, which ones are using memory. Okay. And it's also a live feed of what's going on. You're seeing in real time how the processes are running. Okay. So I'm going to hit Q again to exit out of here. One more helpful thing about top. Let me go back to it here. If you kind of forget how to use it or you're not sure what you're doing, just press H for help. And I'll actually show you some helpful commands here on top and things you can use. Okay. Again, to get out of here, you can type Q or escape like it says at the bottom here. So I'm going to type in Q for quit. I'm going to type in Q again to get out of here. I'm going to clear my screen. Heading back to our PowerPoint. We can use PS command to check the service is running and seeing the tree of the process and also identify the PID of that process. So if you want to see the process ID of a command, PS is a good way and a quick way to check that out. And we can also kill the process which is putting a lot of load on our CPU. Okay. So a lot of times when you're administering a system, such as myself at IBM, I have processes that are using up a lot of CPU, and I need to kill them so that my machine can get back some of its CPU. So I'll have to run that PS command. I'll see what processes are running, and I'll also run top to see which ones are using the highest amount. And from there, I'll take the process ID and I'll kill it so the system gets some of its resources back. Okay. Let me go ahead and show you that real quick. So I'm going to start that sleep command again. And I'm going to put it in the background. And if you guys remember to put it in the background, we use the ampersand symbol. Okay, I'm going to hit enter. So now we can see that process is running in the background. So we see it's job number 2, and it actually gives me the process ID here. But I'm going to go ahead and type in PS. You can see here we actually have 2 processes running for sleep. I'm going to kill them both. I'm going to do it one at a time. So to kill it, I'll type in kill. And then I'll type in the process ID here. Okay. The nice thing about the terminal is you can actually copy and paste if you like to. So I can highlight that number. I can right click and press copy. And then I can paste it here if you don't want to type it out. Okay. And then I'll run PS command again. Ooh, so interesting. You'll see it didn't actually kill it. So what we're going to do is we're going to do kill -15, which means kill that process, but do it gently. And we're going to copy and paste that again. Let's see if it'll kill it this time. There we go, and you can see that time that did actually kill the process and that it finished here. Okay, we're going to kill that other one too, so we'll do kill. We're going to do -15. I'm going to copy that process ID. We're going to kill that off. We're going to run PS again. Let me clear my screen so you can see what I'm doing here. We're going to do PS, and you can see, oh, it's still there, actually. Let me try it one more time. Okay, so we're going to try something else here. We're going to do a kill -9, which means kill it immediately and don't do it nicely. We're not going to be polite about it. I want you to stop now. So we'll take that process ID. Let's see if it stopped at that time. There we go. That time it actually killed it. Okay. So I'm going to go ahead and add.
Thanks for watching. Please like and share this video.
Add that info into the PowerPoint slide for you guys. So that kill-15 will kill a program gracefully, and it's going to allow it to actually run some code and finish out what it's doing. As you can see, though, sometimes that doesn't always work, and we need to actually kill the program immediately. So we can do a kill-9, and this will terminate the program immediately without running any code before exiting. Okay. So I always recommend just trying to run that kill command first. Clean up the slide for you a little bit. Okay. So I always recommend running that kill command first with the process ID. If that doesn't work, you can try the kill-15 in process ID. If that still doesn't work, you can do the kill-9 process ID. So you want to usually do it in that order. You want to try and shut it down as gracefully as you can without being too abrupt with it. So in summary, we went over the UNIX process model, we went over process states, and we went over monitoring and controlling processes. And we even got a little bonus info there, as you can saw, as you were able to see and watch that some of the processes weren't exiting. So we actually used some different flags on that kill command to actually stop the processes. The next session, we're going to be covering a lot of info. We're going to be covering file system organization, file types, file and directory naming rules and conventions, commands for navigating the file system, introduction to inodes, ownership, permission, and dates, manipulating files and links, determining disk usage, and other file system utilities. And guys, if you're struggling to kind of catch on to these things, if you need additional help, please follow these links and look up the private tutoring sessions for system administrator management. There are weekly and monthly plans available. There's also Linux and Bash scripting private tutoring sessions available. As always, thank you so much for joining me. I really enjoyed having you. I hope you enjoyed kind of watching and going through controlling some of these processes. And I really hope to see you next time on our next session. Hey guys, welcome back to session 5 of Introduction to Linux OS. My name is Kevin Downs and I'm super happy to have you back with me here today. Today we're going to be going over the Linux file system, okay? So in session 4 we covered the UNIX process model, process states, and monitoring and controlling processes. Today we have quite a bit to cover, so we're going to go through it as best we can and we'll take some breaks and show you some examples of things that we're talking about. But we're going to be going over the file system organization, file types, file and directory naming rules and conventions, commands for navigating the file system, introduction to inodes, ownership, permissions, and dates, manipulating files and links, determining disk usage, as well as other file system utilities. So starting off here, let's go ahead and cover the file system hierarchy here a little bit again. You'll kind of remember this picture from the last session. So at the very top here, we're going to have our root. Remember, don't get this confused with the root user. This simply just means that this is the beginning of the file system. And underneath that, we can have a lot of other files and directories here. So we can have bin, opt, boot, root, dev, sbin, and others. And below that, we can have even more directories and files here. sbin, lib, include, bin, cache, log, and so on. So if we were to write this out, let's say we wanted to do the beginning of the file system and boot and then bin. We would do /boot /bin/. Okay? So actually let me write that out for you here on our terminal. So if I wanted to go to something like that, I would do slash, oops, I would do cd space slash bin, and then slash, let's do like lib, okay? It would be written out like that, okay? And now this is just an example. In this case, this doesn't actually exist on this system, so it's going to tell you no such file or directory, but that's how it would be written out, okay? So on a Linux file system, a file system is a logical collection of files on a partition or disk. A partition is a container for information and can span an entire hard drive if desired. Your hard drive can have various partitions which usually contain only one file system, such as one file system containing the slash file system or another containing the slash home file system. Okay? Now this is really helpful because you can kind of separate everything and they don't have to rely on one another. One file system per partition allows for the logical maintenance and management of differing file systems. Okay, this is actually pretty common practice on Linux file systems, is to actually separate them into their own partitions. So if I actually bring up our machine here again and I run this command, don't worry too much about this command, we're going to go over it a little bit later. If I run the df space -h, you're going to see all these different file systems here, and they can be mounted on different points. Okay, so these all can have their own partitions here, and they're all separate from one another. So a Unix file system is a collection of files and directories that has the following properties. First, it has a root directory, or slash, that contains other files and directories, and then each file or directory is uniquely identified by its name. The directory in which it resides and a unique identifier typically called an inode. By convention, the root directory has an inode number of 2, and the lost and found directory has an inode number of 3. Inode numbers 0 and 1 are not used. File inode numbers can be seen by specifying the -i option to the ls command. So let's go ahead and check that out here. So if I do an ls space -i, you'll see here that we have these particular directories, and it's going to list their inodes next to them. Okay, so these are all the inodes for these directories. So it is a self-contained, and there are no dependencies between one file system and another. Okay, so all this means is, like I said earlier, when you partition all these file systems into separate places, you keep them separate from one another, and this allows for management of them to become much easier. It also allows the file systems to be dependent on one another, meaning that if something goes wrong on one, it's not going to affect your other file systems. And this is a very smart thing to do, so that if something crashes, it doesn't affect the whole system. So file system organization here, directory and description. So a slash, as we've talked about, this is the root directory, which should contain only the directories needed at the top level of the file structure. Slash bin, this is where the executable files are located. These files are available to all users. And then we have slash dev, D-E-V. These are device drivers. And then we have slash etc or etc. You're going to hear people commonly refer to that as slash etc. This one contains a lot of things in it, and this is where a lot of things are going to be done as a system administrator. So this will contain supervisor directory commands, configuration files, disk configuration files, valid user lists, groups, Ethernet, hosts, and where to send critical messages, as well as a lot of other things. And then we also have some other important files here. So the first one's going to be slash etc or slash exe and slash password. Okay. So this stores user information like username, UID, home directory, and shell, etc. So let me go ahead and open up our VirtualBox here. Let me show you what's in that file. And it's important to know what's actually in all these files, because they do contain useful info. Okay, so there's a lot on the screen. Let's just go over the first part here, or maybe just one of these here. Okay. So let's focus on this guy here, the USM BMUX. Okay. So in this first field here, this is going to be the user. Okay. Second field here, where you see this X, that's a placeholder for the password. This third field is going to be the user ID. Fourth is going to be the group ID. Fifth is going to be the comment field, so you can leave a comment in there, maybe describing what it is. The next field is going to be the home directory of this user. And lastly, this is going to be the shell of the user. Okay. In this case, you see a /usr/sbin/no-login. What this means is that this one in particular actually has no shell, and a shell is just the terminal. Okay. Typically, when you see this, this means that this user is actually not a real user, and instead it's a system user, meaning that something on the system uses this ID to do things on the system. Okay. This isn't an actual user that logs in. Okay. Go back to our PowerPoint here. Next one's going to be /etc/shadow. So this is actually where user passwords are stored. So we saw in that etc password file that it was just an X where the password should be. Well, in this etc/shadow file, this is where the passwords are actually stored. However, they're going to be encrypted. And in there, you're going to see that the first field is the username. Second is the actual password, but encrypted form. Third is going to be the last changed. Fourth is minimum days, meaning how many days do you have to have this password. Next is going to be max days, meaning for how long can that password actually be set before you have to change it. The following field is going to be warned days, meaning how many days can the password be expired before you get warnings and you have to change it. The next field is inactive days, how many days the password can be inactive. The next field is going to be expiry days, how many days the password's been expired. And then finally, the last field is going to be reserved for future. Let's check that file out real quick. So we're going to do cat. Remember, cat is how you look what's inside files. And we'll do /etc/shadow. And shadow, of course, is kind of mysterious. You know, it's where we store our passwords. So you see it says permission denied. So in this case, I actually need to elevate my privileges. So I do sudo. And then I'll do cat /etc/shadow. This is important. This is a good security feature, so not anyone can just look at this file. It's going to ask me for my password. And now we can actually see what's in this file here. Okay, so you'll see in this file you'll have that little star sign, and that's where the password's being stored at. In this case, all of these are system users, and so we don't actually have a password. But if you go all the way down, you can see here, you see Kevin, that's my actual user. And then you see this huge line of numbers and symbols. Okay, that's the password. It's just an encrypted form, so we can't actually see the password. You need to run an algorithm to unencrypt it to actually see my password. But this does tell me that I do have a password in there. And all these other users you see here are all system users, and they don't have a password. So next file we're going to look at is etc group. This is where it stores group information like group name, group ID, and other information. So I'll cat that file real quick, cat/etc/group. And you see we just have some groups here. You know, input, render, syslog. These are all groups on the system. Next we have etc gshadow. And as you can imagine, that's going to store the passwords for the groups. Okay. And then next we have etc password, and then we have a small little dash next to that. Okay. Let's see if I can zoom in on that for you. Oops, too much. There we go. Okay. So you can see there we have a small slash or dash, a small dash next to that etc password. This is going to be a backup of the etc password file. Same with this next one here, etc shadow dash. That's going to be a backup of the file. Okay, and that last one there, oops, sorry, we skipped a few. So we have etc default user add. So whenever a user created, the user's default settings are taken from this file. And then we also have etc/login/defs or defaults. This is the user's login default settings information whenever they are created and logging in. Okay, and then that last one is going to be /etc/skel, SKEL. So this stores users all the user's environmental variable files, and they're copied from this directory to a user's home directory. So when a user is created, the contents in etc are sent to this other user, and that creates a home directory.
Thanks for watching. Feel free to add your questions as comments down below.
For them. Okay, I am going to show you the login defaults here just so you can kind of see what's in there. So I'm going to cat the file /etc/login defaults. Okay, and we can see some default settings here. In this case, there's not a lot going on in here, just because by default there isn't much set. I can set some settings in here though, and this would create the defaults for the user. So let's talk about file types. When navigating the Linux file system, you are sure to encounter different file types. The most used and obvious file types are regular files and directories. However, the Linux operating system has more to offer in terms of file types, as it also includes another 5 file types. Okay, so in here we're kind of looking at the output of ls-l, or long listing, which I explained in a previous video. I'm going to explain again here to touch on the topic. So I'm going to do a ls-l. You can see here we have several fields, the first of which is going to be file type. Okay, so we see D here. That means it's a directory. Okay, and we see all these here are directories, except for test. You notice test does not have anything there, it's just a dash there, which means it's just a normal file. Okay, and in this next column, we see different permissions here. Okay, the R stands for read, the W for write, and X for execute. Okay, you're going to notice 9 spots here. I can highlight it all. You're going to notice 9 spots here. Okay, so this is going to stand for user, group, and other. So in this case, the first 3 we see are all marked here: read, write, execute. This means the user has read, write, and execute privileges. The next 3, we only see R and X. You'll see a dash in the middle. Whenever you see a dash, that means that that permission is not set. So in this case, the group only has read and execute permissions. And then we'll notice the same for other. In this case, other only has read and execute permissions. In this next column, this just tells you how many hard links are set to this file. And then we see here the user owner of this file, which is Kevin, meaning the user owner Kevin can read, write, execute anything on this directory. Then we also have group. This means anyone in the group Kevin will have read and execute privileges on the desktop directory. Okay? And now other would mean anyone outside of these 2 specified, user and group, would be other. In this next column we have the size of the file, which is displayed in bytes. And then the following column we have when it was last modified, and in the last column we have the directory itself. Alright, so we've seen how to kind of navigate the file system. Let's go ahead and talk about how the file system and directory are named. So all files are case sensitive. So a file name of vivek lowercase .txt, capital V vivek.txt, and all capital vivek.txt are all actually 3 different files. You can use upper and lowercase letters and numbers and dots and underscore symbols to actually name a file. In short, file names may contain any character except the / character, okay? Because this is reserved as the separator between files and directories in a path name. You cannot use the null character. Most modern Linux and Unix limit file names to just 255 characters, or 255 bytes. However, some older versions of Unix systems limit file names to just 14 characters only. A file name must be unique inside its directory. For example, inside of /home/vivek directory, you cannot create a demo.txt file and demo.txt directory name. Okay, so you can't have demo.txt and demo.txt directory in the same directory. However, other directories may have files with the same names. For example, you can create demo.txt directory in /temp. So I can have demo.txt in /temp here, and I can also have it in /home/vivek, okay, because those are different directories. So let's go over some simple commands here for navigating the file system. You've seen me do these a number of times. First one's cd, or change directory. This is used to navigate the files in different working directories. We also have ls command, which can be used to view the file system in the present working directory. We have ls space -alh command, and this can be used to view the information of files in the present working directory. And we can also use the du command to check file size, and also use it to check the size of multiple files at the same time. So let's go ahead and go over those real quick. So let's go ahead and list. Actually, let's go ahead and check out where I'm at right now. And if you guys remember, how we check our current directory is pwd, print working directory. So I'm in /home/Kevin. Let's go ahead and see what's contained in /home/Kevin. So I'll do ls list, and you'll see I have all these different directories here, as well as one file, test. Okay. Let's go ahead and change one of these directories. I'm going to do cd, and I want to go to desktop, so I have to do capital D ESKTOP, and I'll switch that directory. Now if I want to go back one, I do cd ... and I'll actually go back one directory. Okay. Now remember, it's case sensitive, so if I were to do lowercase d, it's going to say, hey, I'm not too sure what that is. I don't know that it exists. And that's because we did it as lowercase, so I need to make it uppercase. Okay. So now you'll see here, I'll do my pwd. So I went from /home/Kevin. I cd to desktop here. I did that here. And then now I'm in home, Kevin, desktop. And you'll see here I'll do an ls, there's nothing in here. So let's go ahead and go all the way to that. So if you do cd command without any flag or option on it, it's actually just going to take you all the way back to the root directory of the system, which in this case is home/Kevin. Okay. Go ahead and clear my screen here. So the next command we saw was ls, but it had some flags on it. It had -a, l, h. Okay? So now we see you get a lot of info here. So what these flags mean, -a is all, l is long listing, as you remember from our previous sessions, and h is human readable. So what -a does, or all, is it actually shows you hidden files here. And how you know a file is hidden is by this little period placed in front of it. Okay, so you can see all these here are hidden files. This would not show up if we didn't have that -a flag on it. -h makes it human readable. So you'll see here our size now is in kilobytes, which is a little bit more user friendly as opposed to bytes. Okay, so let's run those commands without those flags on it. So if I do a ls-lh, you'll notice those hidden files are gone. However, you'll see this is still human readable because it's got the size in kilobytes. So let's do an ls-l, and now you'll see that the size went back to bytes here. Okay. Also keep in mind, or be aware, that I don't necessarily have to put all those flags right next to together. I can do -a, -l, -h. That's going to give me the same info. Or I can also run them all together, LAH. And I get the same info again. Okay, so you can separate these or you can keep them as one. But the system knows by putting that dash in front of it that these are all different flags. Okay? It knows that this isn't a word you're putting in. So I could do ls-help, and now the system recognizes that this is an actual word or command that I'm putting in. Okay? And you'll see it lists some help for the command ls. Alright, so let's go ahead and introduce you to inodes. A directory is really just a file, okay? It's a special file, though, with special rules. You can't just type cp/dev/null/directory to erase it, okay? It's got special bits to make sure a mere mortal can't mess it up, okay? So someone like me or you can't just go in and start messing up files or directories. Because if a file system gets corrupted, then you can say goodbye to your data, alright? So if the whole file system gets taken down, then everything in it, contained in it, is going to go away. So it's good that directories have special rules for it. And this is also why we separate the file systems, so that if one goes, they don't all go. So a Unix file is stored in two different parts of the disk, the data blocks and the inodes. The data blocks contains the contents of the file. The information about the file is stored elsewhere in the inode. Okay? Both the inodes and data blocks are stored in a file system, which is how a disk partition is organized, but these inodes are strange and confusing. We will use the ls-i command to check the inode of file and df-i to see the inode of partition. Okay? Also, something else to mention is that when we do the mv command, what we're actually doing is we're changing the inode of that file. Okay? So we're telling the system, hey, we're moving it to a different inode, and now it's being stored somewhere else on the system. So that's what that mv or move command is actually doing. It's changing the inode of that information. Alright, let's go ahead and move on to ownership, permissions, and dates. So we're going to spend a good amount of time on this because this is actually really important info for the Linux system. This is how it stays secure, and this is how a lot of things are run on the system. So file ownership is an important component of the Unix system that provides a secure method for storing files. Every file in Unix has the following attributes. It has an owner permission, or owner of the file, and this determines what actions the owner of the file can perform on the file. It also has group permissions. The group's permissions determine what actions a user who is a member of the group that file belongs to can perform on the file. We also have other or world permissions, meaning everyone else besides the owner and group. And the permissions for others indicate what actions all other users can perform on this file that are not part of the owner or group. So when we run the ls-l command, it displays various information related to the file, such as the permissions of the file. So let's go ahead and look at that real quick. So we'll do an ls-l. And as I explained just a bit ago, in this first column, we see the permissions here. Okay? So that's how we can see the permissions on these files. So the permissions are broken up into groups of threes, and each position in the group denotes a specific permission in this order: read, or R, write, or W, or execute, X. The first three characters, 2 through 4, represent the permission for the file's owner. For example, read, write, execute, read, execute, read represents that the owner has read, write, and execute permissions. Okay, so those first three there. Oops, too much. Let's see if I can highlight it for you. Not quite, but I'll show you on the terminal here. But you see those first three there are for the user. Okay. The second group of three characters, 5 through 7, consists of the permissions for the group of which the file belongs. For example, we have read, write, execute, read, execute, and read. This represents that the group has read and execute permissions. So you see the dash in the middle. This means that write is not set for the group. The last group of three characters, 8 through 10, represents the permissions for everyone else. For example, using that same set of permissions, we see this last group of three here. We see an R, which means read. We see a dash and another dash. This represents that there is read-only permissions. Okay, so let's check that out on our system here. So we'll see for the test file here, that in those first three, we have read, write, execute. Okay, so that means user has read, write, and execute permissions. The next three has read and write only, and then the last three is just read. Okay, so user has read, write, execute. Group has read and write, and then other has read only. Okay, so the user Kevin has read, write, and execute permissions, and the group here, which is also Kevin, has read and write permissions. So, to change the permissions, or to change the file directory permissions, use the chmod or chmod command. There are two ways to use chmod. the symbolic mode or the absolute mode. Let's take a look at the symbolic mode here. So the easiest way for a beginner to modify the file directory permissions is to use the symbolic mode. With symbolic permissions, you can add, delete, or specify the permission set you want by using the operator.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
In the following table. Okay. The first one we have is plus sign. This adds the designated permissions to a file directory. The next we have is a minus sign, which is to remove the designated permissions from a file directory. And finally we have the equal sign, which sets the designated permissions. So an example of how to use that, we have test file. So running ls-l on test file shows that the file's permissions are as follows. So we have ls-l test file, and then you can see there it's read, write, execute, and then read. So using that chmod command, we can use various different ways to change the permissions on it. Okay. So this first one here, we see chmod space O, which is other, plus write and execute. And when we run ls-l again, that gives other the write and execute permissions now. Okay. So you see above it was read only, and now it's write and execute. We can also take away permissions. So chmod space user, U, so U stands for user, minus, so take away, execute permissions. So if you were to run ls-l on test file, you'll see now that execute has been taken away from the user. So before up here we see user had execute, and now execute's taken away. And then we can also use the equal sign. So chmod space G, which stands for group, which is going to be the middle three, equals read and execute. Okay? So we run an ls-l on test file, and now we see the group has read and execute permissions. Okay? So this, using the equal sign, will actually set the permissions. Even if it had write permissions before, it's just going to set it to exactly what you state. Okay? And you can actually combine these commands on a single line. So we can do chmod space other O plus WX, comma, user U minus X, comma, group space equals space read and execute. Okay? So what that's going to do on other, it's going to add write and execute. On user, it's going to take away execute. And on group, it's going to add read and execute. Okay? So let's go ahead and demo this real quick for you guys. A little bit easier to understand on the terminal, I think. So let's go ahead and do an ls just to see what I had. So I have that test file, and that's what we're going to be using to change permissions on. Okay? So let's do an ls-l to look at the permissions here. And you'll see this test file has read, write, execute for user. It has read and write for group. And it has read only for other. Okay. Let's go ahead and do chmod. And let's do other, O, plus, so add. And let's add write to it. Okay. Or let's go ahead and add write and execute, so we can follow the example in the PowerPoint. And then you have to specify the file you're doing it to. Okay? Now let's do an ls-l. And now you'll see that on other, the test file now has write and execute privileges. Okay? Whereas before, it only had write privileges. Okay? Let's go ahead and clear the screen. Now, we're going to do chmod. We're going to do user minus, which means take away, x, execute permissions on that test file. Okay? Actually, let's show the test file. ls-l. So you can see right now user has read, write, and execute permissions. So we're going to do chmod user u minus x execute test. Okay. Do ls-l. And now we can see that the user had execute permissions taken away. Let's go ahead and clear screen. Now on the last one here, we do chmod, or let's do our ls-l first so we can check the permissions. We're going to do chmod. We're going to do group equals read and execute on the test file. Okay. So before we do that, we look here, group, which is going to be the second set of 3 here, has read and write only. Okay. We're going to set it equal to read and execute. Let's hit enter. Oh, interesting. Chmod group, valid mode G. Let's get rid of those spaces. Let's see if that'll. Oh, forgot to put the file. That's why. Okay. Chmod group equals read and execute. There we go. There shouldn't be a space in between the G and read and execute. Okay, so now we'll check it out. And we'll see group now has read and execute permissions. Okay. So let's go back to our PowerPoint. So I want you guys to look at that equal sign example in there. So that space actually shouldn't be in there. It should be G equals RX, no space in between those. Okay. Now in this last example, it showed you how you can combine multiple ones. Let's go ahead and do that real quick. Let's clear our screen. So we're going to do chmod. We're going to do O plus, so add, write and execute, comma, U, user, minus, take away, X, execute permissions, comma, we're going to do group equals read, execute. We're going to do that on the test file. Okay. We'll do ls-l. And we'll see here, so we added write and execute for other. Okay. We took away execute for user. So that's that first one, so no execute on here. And then we made group equals to read and execute. Okay, so second one here, read and execute. All right. Let's go back to our PowerPoint. So changing owners and groups is different than changing permissions. So while creating an account on Unix, it assigns an owner ID and a group ID to each user. All the permissions mentioned above are also based on the owner and groups. Okay. So 2 commands are available to change the owner and the group of files. chown or chown. The chown command stands for change owner and is used to change the owner of a file. And then we also have chgrp or change group. The change group command stands for change group and is used to change the group of a file. So we can see in our example here, the change own command changed the ownership of file, and the basic syntax is as follows. So chown space the user that we're going to be changing ownership for, and the file itself. Okay, so file list will have its owner changed to user. Okay, its user will be changed to user. The value of the user can be either the name of the user on the system or the user ID of a user on the system. Change group follows a pretty much similar syntax. So we do change group space, the group you want to change it to, and then the file you're changing. Okay. So in this example, file list will have its group owner changed to group. The value of the group can be the name of the group or on the system, or the group ID of a group on the system. Okay, so let's go ahead and show you that real quick. Clear my screen here. We're going to be using test file again as our example, so we'll do ls-l. You'll see on test file here, the user owner is Kevin, and the group owner is also Kevin. So let's do change own, chown, and I'm changing it. We're going to change it to root, and the file I'm changing is test. Aha, so you see it says operation not permitted. Okay, so I need to elevate my privileges. So I'm going to do sudo. I'm going to run that same command. Okay. It's going to ask for my password to elevate my privileges to root. Okay, so now if I do an ls-l, you'll see that the user owner of test was changed to root here. Okay. So let's go ahead and clear our screen. Do an ls-l. You see the user owner is root. Let's go ahead and change the group now. Change group. The group you want to change it to, which is root, and then the file you want to change. And again, I didn't do sudo, okay? So I have to do sudo to elevate my privileges because only root can do this action. And then I'll do root. Let me put change group first. Root test, okay? And that password I was putting in when I did sudo, guys, is just the password you use to log in your machine. So I'll do an ls-l, and you'll see here that test is now owned by group root, okay? Let's go ahead and change those back real quick. So sudo change own. I want to change it back to Kevin. I'm changing the file test, okay? Now you'll notice this time it didn't ask me for my password for sudo, and that's because I've put it in a few times now, so the system just recognizes that I do have those privileges. So we're going to do that again. I'm going to press up, and I'm just going to actually change own to change group, so I don't have to type all that in again, okay? I'm going to do an ls-l, and you'll see here that the user and group was changed back to Kevin, okay? It's not too difficult. All right, now the other way to change permissions is actually the symbolic way, okay? So this can be a little tricky, so I suggest writing this down or maybe looking up a little bit more about how these permissions are written. So each read, write, and execute has values assigned to them, okay? So the value for read is 4, write is 2, and execute is 1, okay? And null is 0. So the total value for read, write, and execute permissions is 7. So as an example here, if I were to do the change mod command, I would do chmod space 774, and I'm changing file 1, okay? So what this says is the user here, the first set here, is going to have read, write, and execute. So 4 plus 2 plus 1, all right? I'm turning on all permissions for that user, okay? For the second one here, I'm also doing 7. So 4, which is read, plus 2, which is write, plus 1 is execute, and that equals 7, okay? And that's for the group. And then for other, I'm only doing 4. So since the value is 4, that equals read. So I'd be changing other to just read. So another example here. Chmod 4 plus 2 would equal 6. So for the user, I'm granting read and write privileges. For the group, I'm granting read and write privileges because 4 plus 2 is 6. And then for other, I'm putting in 0, okay? So 0 means I give them no permissions, okay? So for file 2, that's going to change the permissions to read, write, and none, okay? Let me go ahead and show you that on the virtual box here. Let me clear my screen. So we're going to be working with test file again, or just test, sorry, the file named test. I'm going to do chmod. I'm going to do 777 test. And then when I hit enter, it's going to change all these permissions here to read, write, execute, read, write, execute, read, write, execute. And as you see there, it in fact did change all those to read, write, execute, read, write, execute, read, write, execute. Okay. Let me clear my screen. So when we're changing those permissions using this way, it has to add up to something. I can't just put a 3, okay? I can't put like 3, 3, 3, okay? Because that doesn't make sense. Read is 4, write is 2, and execute is 1. Actually, that does make sense. Sorry. Simple math, simple math. 2 plus 1 would equal 3, okay? But I can't have a number like 9, okay? Because no combination of read, write, and execute would equal 9. I can't do that. See, invalid mode, 999. Doesn't make sense, okay? I could actually do 333.
Thanks for watching. Please like and share this video.
Okay, and what that would do is it would give write and execute permissions, okay? Because remember, read equals 4, write is 2. Actually, let me go back to PowerPoint here, show you. So read is 4, write is 2, and execute is 1, okay? The only way we're going to add up to 3 is if we do 2 plus 1, meaning write and execute, okay? But there's no way I could ever make these 3 equal 9, okay? So it has to equal a combination of these numbers. So if I do that, I do an ls-l, or let me run that command first, and then ls-l. You'll see now that test just has write execute, and write execute for user, group, and other. Okay? Alright guys, we are on the home stretch here. We're almost done with this session. We're going to look at manipulating files and links here. So to work with files and links, we use the following commands, which we've seen a couple of times now. CP, which is copy files and directories. MV, which is move or rename files and directories. RM, which is remove files and directories. And mkdir, make directory, which is create directories. These 4 commands are among the most frequently used Linux commands. They are the basic commands for manipulating both files and directories, okay? And we've demoed those a couple times now, so you should be fairly familiar with how to actually use these commands now. A couple other commands we can use on our system is the df command, which stands for disk free. So this shows the amount of disk space used and available on the Linux file system. We also have the du command, which stands for disk usage. So this displays the amount of disk space used by specified files and for each directory, okay? So this can be a little confusing at first. So think as df is like a whole picture of the system, okay? It's going to list all file systems and how much space is available on them. Du is going to be like a specific snapshot of a certain directory and what's being used on it, okay? So let's go ahead and take a look at that now. So if I do df command, it's going to show you all my file systems here on this left side. And it's going to show you how much available space is on it. Okay, so you see all these 0%, 1%, and all these are actually completely full. But we don't have to worry about that. Let's take a look at slash here. Okay, it's 62% used. Alright, let's go ahead and cd to slash. Okay, and we're going to do pwd. It's going to say we're at slash. So now we're going to run the du command. Okay. So du, and we're going to specify, well actually we don't need to specify slash since we're right here, so we're just going to do du. Now, you're going to see a ton of stuff be outputted, okay? So it's actually showing us every single file in slash and what's being used by it, okay? I don't actually want to see all these, so what I'm going to do is I'm going to click Control-C, and if you guys remember, that's the signal interrupt command. Oh, well, it actually finished. But if I would have clicked Control-C, it would have stopped that command, right? Obviously, I'm not going to look through all of this to see what's taking up the space. Okay, but that does show every file under slash and what's actually using the space. Okay, so let me clear my screen here. We can also put a -h flag on the df command. This can be human readable. Okay, so now it actually shows it to me in megabytes and gigabytes, which is a little bit easier to understand instead of kilobytes and bytes. Okay, I can do the same with du. I can do du-h. And again, it's going to run all through that, and it's going to put it in kilobytes. Or sorry, gigabytes and megabytes. I'm going to hit Control-C, I'm going to stop it. So stop that command. I don't need to see all that. So that's the difference between df and dh. df shows you a grand picture of the whole system. Du shows a snapshot of a specific directory you're wanting to look at. So a file system is a way in which files are named, stored, retrieved, as well as updated on a storage disk or partition. It determines the way files are organized on the disk. A file system is divided into 2 segments called user data and metadata. User data is typically local data that individuals need to complete to specify their tasks. So this data is kept in the /home file system, or file systems are created specifically for user data. Metadata is just data that provides information about other data. Okay, so that's typically the difference between these two. So metadata can be file name, time it was created, modified time, its size and location in the directory, hierarchy, etc. File systems can also have several different types, the most common being ext2, ext3, ext4, and XFS. So you'll see here in this picture below, we see some files, we see the file system type, we see NTFS, VFAT, NTFS, swap, ext4 there. So we actually go back to our machine here. If you do a df-h and then capital T for type, it'll show you the type of file systems here. Okay, so we see some different ones here: squash-fs, temp-fs, VFAT, but we do see the ext4 there. Okay, so this is the type of file system it is. Okay, you don't have to worry too much right now about what types of file systems mean. Just be aware that there are different types of file systems, different formats. So in summary, we went over file system organization, file types, file and directory naming rules and conventions, commands for navigating the file system, introduction to inodes, ownership permissions and dates, manipulating files and links, manipulating directories, determining disk usage, and other file system utilities. Next session, we're going to be doing I/O, which is input, output, redirection, and pipes, command separation and grouping, background execution, file name expansion, shell variables, command substitutions, quoting and escaping meta characters, Z-shell features, fish shell features, command execution, startup files, and customizing the user environment. Again, guys, please, if you're struggling with any of these concepts and need just a little bit of extra help, please check out our private tutoring sessions for system administrators. We have weekly and monthly plans available, as well as Linux and Bash scripting private tutoring sessions. Just click on this link and follow it to the website. Thank you so much for joining me. I look forward to seeing you in our next session, and I hope you learned a lot today, guys. You're starting to feel a little bit more comfortable with this system. Hey guys, welcome back to session 6 of Introduction to Linux OS. Today we're going to be going over shells, pipes, fish, and Z-shell. So in session 5 we covered file system organization, file types, file and directory naming rules and conventions, commands for navigating the file system, introduction to inodes, ownership, permission, and dates, manipulating files and links, determining disk usage, and other file system utilities. Today, we're going to be going over input, output, redirection, and pipes, command separation and grouping, background extension, file name expansion, shell variables, command substitution, quoting and escaping meta characters, Z-shell features, fish shell features, command execution, startup files, and customizing the user environment. So let's go ahead and dive right in. Let's talk about input and output redirections. Most Unix system commands take input from your terminal and send the resulting output back to your terminal. A command normally reads its input from the standard input, which happens to be your terminal by default. Similarly, a command normally writes its output to standard output, which is again your terminal by default. Output direction is when the output from a command is normally intended for standard input, and it can easily be diverted to a file instead. This capability is known as output direction. Okay, so let's take a look at this example down here. So if the notation > file is appended to any command that normally writes its output to standard output, the output of that command will be written to the file instead of your terminal. So when we look at this example, we see who, which is a command, is redirected to this file users here. Okay. So standard input, in this case, is going to be this command input, or command who. Its output would normally come back to the terminal and show us the result of this command, but instead, this greater than sign is directing it to the file users. Okay, so the output from who is getting redirected to users. Okay, so let's go ahead and run that command real quick. So I'm going to write who, WHO, which is a command. Let me show you what this command normally does. So this just shows you what users are on the system. So I'm going to do who. I'm going to redirect that to a file called users. Okay. In this case, the file users doesn't actually exist yet, but since I'm running this, it's going to go ahead and create that file for me. I'll hit enter. I'll do an ls. You'll see the file users now exists. And I'm just going to cat what's in that file. And you'll see in that file is the output. So the standard input was who. The output of who got redirected to the file users. And then we see that the standard output was placed in file users. So let me see back in our PowerPoint, it's saying that you notice no output appears at the terminal, and that's because it was redirected to the file users. If a command has its output redirected to a file and the file already contains some data, that data will be lost. Okay, guys? So that's important. Keep in mind when you redirect something to a file, if there's info already in that file, it's going to be deleted and replaced with what you're redirecting. Okay? So let's look at the first example here. So we say echo line 1 into users, and then when we cat users, we'll see that it says line 1. Okay? If anything else was in that file, it would actually be deleted. Okay? Alternatively, you can use two greater than signs, and this is going to append the output into the existing file. So we'll actually add whatever data or whatever output you're doing, and it's going to add it to the end of the file. So we look at our second example here, echo line 2, greater than sign, users, and we cat users, and it's going to say line 1, line 2. Okay, so let me show you that real quick. So cat users, you see that's in there. Okay, so I'm going to say echo line 1 into users. Oops. So actually I made a new file on accident. Users, there we go. I'm going to say cat users. And you notice it says line 1 now. So if I say echo line 2 and I append it to users, and now I cat users, you'll see that it's actually added to the second line. Okay? So as the greater than character, which is this character here, is used for output redirection, the less than character is used to redirect the input of a command. Upon execution, you will receive the following output. You can count the number of lines in that file by redirecting the standard input of the word count command from the file user. So we see here you can actually use that symbol to redirect the other way. Okay, so we have the file users here that's going to be sent into the command word count. Okay, so let me show you that for you real quick. Let's clear our screen. So Control L. I'm going to do word count -L, and all this does is count the number of lines in a file. And it tells me there's 2 lines. So it sent the input from the file users and it redirected it into this command. Okay? A here document is used to redirect the input into an interactive shell script or program. The general form for a here document is command space less than space delimiter. Okay? Here the shell interprets the less than operator as an instruction to read input until it finds a line containing the specified delimiter. Okay? All the input lines up to the line containing the delimiter are then fed into the standard input of the command. The delimiter tells the shell that the here document has completed. Without it, the shell continues to read the input forever. The delimiter must be a single word that does not contain spaces or tabs. Okay, so it's looking for a specific delimiter, and once it sees that, it's going to stop reading it. Okay, and guys, just so you know, we're covering this at a very high level. Okay, so no need to try and understand this too much. It's going to be covering in much more depth in our next course, Intermediate. Okay. In this section, we're going to discuss briefly about pipes and filters in Unix. You can connect 2 commands together so that the output from one program becomes the input of the next program. 2 or more commands connected in this way form a pipe. To make a pipe, put a vertical bar, which is this symbol here, and that's usually going to be above your enter key, on the command line between 2 commands. When a program takes its input from another program, it performs some operation on that input and writes the result to the standard output. it is referred to as a filter. And this is commonly used with the grep command here. Okay, so we see here the grep command searches a file or files for lines that have a certain pattern. And that's going to be grep space, the pattern you're looking for, or the text you're looking for, space what file you want to use it on.
Thanks for watching. Feel free to add your questions as comments down below.
Okay. The name grep comes from the ed, a Unix line editor command, grep, which means globally search for a regular expression and print all lines containing it. Okay. Again, pipes are going to be covered in much more detail in our next course, Intermediate Linux. The simplest use of grep is to look for a pattern consisting of a single word. It can be used in a pipe so that only those lines of the input files containing a given string are sent to the standard output. If you don't give grep a file name to read, it reads its standard input. That's the way all filter programs work. Okay? So in this example here, we have ls-l space pipe space grep space and then quotation marks AUG for August. So it's going to take the output from ls-l, it's going to send it into this command grep, and it's going to say search for all things that have the word August in it, AUG, and it's going to send you back what it finds. Okay. There are a couple different options you can use with grep, such as -v, which prints all lines that do not match the pattern, -m, which prints the matched line and its line number, as well as -l, which prints only the names of files with the matching lines. The sort command arranges lines of text alphabetically or numerically. The following example sorts the lines in the food file. So we do sort food, and it sorts it here. You can see the example here. It's going to sort it alphabetically. By default, it's going to actually sort it alphabetically. Okay. All right, let's go to our next slide here. More than two commands may be linked up into a pipe. Taking a previous pipe example using grep, so the example we just used, we can further sort files modified in August by the order of the size. So let's take a look at our example here. We have ls-l space pipe space grep space August space pipe space sort space +4n. Okay, so the output of ls-l is getting piped into the input of grep August, which is getting piped into the input of sort +4n. Okay, so sorting everything by August. You see that here. So this pipe sorts all files in your directory modified in August by the order of size, and then prints them on the terminal screen. The sort option +4n skips 4 fields. Fields are separated by blanks, and then sorts the lines in numeric order. Again, we're going to be covering pipes and filters much more in depth in our next course, Intermediate Linux. So no need to worry about it too much right now. Alright guys, let's talk about command separation and grouping. So Bash provides two ways to group a list of commands to be executed as a unit. Placing a list of commands between parentheses causes a subshell environment to be created. See command execution environment for a little bit more details on that. And each of the commands in the list to be executed in that subshell. And we'll see here some common commands to be used for that. So add user, user delete, add group, delete group. And let's talk about background execution. So in Linux terminology, and in Unix in general, a background process is a process that is started from a shell or terminal and then runs independently. When a background process has been launched from a terminal session, the same terminal will be immediately available to execute other commands. In contrast, a foreground process takes control of the terminal when launched, preventing any other command to run until it is finished. And guys, we saw this in our last session when I was running that sleep command. When I ran it in the background, when I did sleep 60 and then I did that ampersand sign, it was running it in the background and I could still use my terminal. However, when I ran it in the foreground, you saw that I wasn't able to use my terminal. So let's look at the example below. So when I run yes example 1 and I redirect, so you see that greater than sign, redirect the output of this into the input of this, it'll take control of the terminal. Okay? And the only way to get out of that would be to run a signal interrupt or a signal suspend with Control Z or C. So let's go ahead and check that out real quick. Let me clear my screen here. So I'll do yes, example 1, and I'll redirect that into /dev/null. You'll see I lose control of my terminal here. So the only way to get out of that is Control-C or Control-Z. Okay. Let's go ahead and talk about file name expansion. Another way to save time in your commands is to use special characters to abbreviate file names. You can specify many file names at once by using these characters. This feature of the shell is sometimes called globbing. Okay, so anytime you hear the word globbing from someone else, they could be referring to file name expansion. So MS-DOS or MS-DOS, which is Microsoft or Windows, provides a few crude features of this type. You can use a question mark to mean any character and an asterisk to mean any string of characters. Okay, Unix provides similar wildcards to this, but in a more robust and a rigorous way. So let's take a look at the example below. Let's say you have a directory containing the following CSource files. So ls, you have your first file here. Oops. Okay. Second file here. Oops. Too much. There we go. Second file there. Third file. Fourth file. Fifth file. Okay. So to list the 3 files containing digits in their names, you could enter docstore.mik.ua/O'Reilly/Linux/run/chapter4a.htm. Okay, so we could do an ls, and we could throw that question mark in the middle there, and you see it's going to list the ones with the numbers in their name. Okay, 1, 2, 3. So the shell looks for a single character to replace the question mark, thus it displays those 3 files, 1, 2, and 3, but not the last one, because that name contains too many characters, as you'll see here. Let's go and talk about shell variables here. So variables can be created either at the shell or in shell scripts. Any variable created with a shell script is lost when the script stops executing. A variable created at the prompt, however, will remain in existence until the shell is terminated. So here we see our prompt. Okay. And then we see my var equals 999. So when we echo my var, it's going to say that variable equals 999. Okay. So variables are designated by that $sign. Okay. Let's go ahead and take a look at that real quick. So we're going to say my var equals, let's make it a different number, 789. Okay. We're going to echo the my var variable, so we're going to say echo space $sign, and we have to make it spelled exactly right because remember Linux is case sensitive. It's going to say that equals 789. Okay. There's also a couple other variables by default in Linux, such as user. So we'll say echo $user, all capital. It's going to say the user's Kevin. Same with home. So we're going to say echo $home. What is that variable? And it's going to tell you your home directory. Okay. And you can see that here in the PowerPoint. You know, it says variable user. So echo RAM and then the variable user, and it's going to say RAM Datasoft. Datasoft's the user. So there's some more examples of shell variables. We can say echo RAM, and you'll see here user is not spelled correctly. It's all lowercase, which is incorrect. So it's only going to echo RAM because that's not the correct spelling of the variable user. We also see here echo this is the and then shell variable Datasoft. So it's going to give you the variable for the shell environment you're using. So this is the /bin/bash Datasoft. We see another one here. We can use multiple variables in one line. So echo this is the shell variable on computer hostname variable. So this is the /bin/bash on computer Datasoft. So we have our shell variable here. We have our host variable here. Another example, echo the user ID of, and then we see user is spelled incorrectly again. It's all lowercase. Is, and then the user ID variable. So we're only going to get the user ID variable here. The user ID of, and then blank because it's in the correct spelling, is, and then user ID variable. Okay. And then another one, echo my home dir or home directory is, and then home directory variable. So it's going to output my home directory is /home/Datasoft. All right, moving along. Next we have command substitution. So command substitution is the mechanism by which the shell performs a given set of commands and then substitutes their output in place of the commands. So here's an example. The printing value of the variable is submitted by its value, and at the same time the /n character is substituted by a new line. Okay? So whenever you see this is actually a script. It's called a hash pling. Okay, this just designates the script and the shell environment you're going to use, but don't worry too much about that. So we see we're setting the variable a equal to 10. We're going to echo -e, okay, and this just means interpret this slash here. So we're going to echo -e / value of a is, and then the variable a, and the output of that is value of a is 10. Okay. Some more on command substitution here. Command substitution is generally used to assign the output of a command to a variable, and this is very useful for when we're writing scripts. Each of the following examples demonstrates the command substitution. The first one here, we're going to substitute the variable date with the actual command date. Okay, so when we echo date is variable date, we're going to actually get the output the date is and whatever the date is. Okay, same with users. So in here we're going to put the user's variable equal to the variable, so you see $sign here to designate it's a variable. Command who, pipe, and then the word count of who. Okay, and then finally we have echo logged in users are and the variable of users. Okay, and it's going to give you the output of this. And the last example we have here, the variable up equals, and then we're going to use the date command and uptime command. We're going to put both the outputs of that into the variable up. And we're going to echo uptime is variable up, and it's going to give us the output of that. So let me go ahead and open my VirtualBox here and kind of give you examples of that and show you how that actually works. So first in here we're going to say set the variable date equal to, we're going to do double quotation mark, $sign because it's a variable, and then parentheses, open parentheses, date, and then close parentheses and double quotation mark. So now we set the variable date equal to the command date. Now when we do echo date is, and then we're calling a variable, so date close parentheses. Oops, spelled that wrong. Oops. Spelled it wrong again. Alright. We're going to get the command there. Date is Thursday, 13th of August, 2020. It gives me the time and time zone there. Okay? Let's do that for users as well. Users equals double quotation marks, $sign, open parentheses, who, space, pipe, space, word count, -L, close parentheses, and close quotation mark. And we're going to call that variable. We're going to say echo parentheses logged in users are. We're going to call the variable users, and we're going to close parentheses. So say logged in users are 1. There's only one user logged in. Finally, we're going to make the variable up equal to quotation mark $sign parentheses date command semicolon, because we're running two commands here, uptime, which is also another command, close parentheses, close quotation mark. Now we're going to echo uptime is, and then the variable up, close parentheses. Uptime is the date, and then the command uptime. So let me go ahead and show you separately what those do. So date command gives you the date, and uptime gives you how long this server's been up. Okay, so when we run the uptime command, it shows you how many users have been on it, the load average, how long it's actually been up, and when it was brought up. Okay, so you'll see here these two commands were used in concurrent for that one variable. Let's go back to our PowerPoint. So next we're going to look at quoting and escaping meta characters. There are three options to avoid shell interpretation of meta characters. So we can escape the meta characters with a backslash. We can use single quotes around a string. Or we can use double quotes run a string. Now take note, single and double quotes protect each other. So if we look at the examples below, we do echo, hi, intro to UNIX class. So we have single quotes on the outside here, and we have double on.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
The inside here. So when we do that echo, it's going to say hi, and it's going to keep the double quotation marks there. Hi, intro to UNIX class. Okay, so these single quotes say, hey, take this literally, echo exactly what I have inside of here. Okay. Reversely, we have the same thing with double quotes. Echo, double quotes, hi, single quotes, intro to UNIX class, single quote, class, and then double quotes. It's going to say hi, and you'll notice the single quotes here, intro to UNIX class. So these are just protecting and saying, hey, whatever's inside of here, interpret it literally, okay? And then the backslash character will do the same thing for special characters. So we say echo, double quotation mark, backslash, meaning, hey, ignore this next one here, interpret it just as it is, 9,800 double quotes, okay? So if we weren't to put that there, it would actually look at this as a variable. It'd say, okay, well, I'm going to go look for the variable 9,800. We're using this backslash here, and now it's just saying, hey, ignore that, interpret it as is. So it would echo out $9,800. Okay, let's go ahead and talk about some different shells that are available. Don't worry too much about these or how to get them or what they do, guys. Just be aware that there are additional shells available outside of the normal shells that we use. So by default, most people are going to use the bash shell, B-A-S-H, which stands for Born Again Shell. This is the default shell. However, we do have other shells such as the Z shell. So the Z shell is a Unix shell that can be used as an interactive login shell and as a command interpreter for shell scripting. Z shell is an extended Bourne shell with many improvements, including some features of bash, corn shell or K shell, and TC shell. So let's head to our VirtualBox here. Let me show you how to get Z shell. So if we want to install Z shell, what we're going to have to do is we're going to have to do a sudo apt-get. So sudo apt-get. Then we'll have to do install Z shell. Install ZSH. So you can see it's loading. And there we go, it's installed. Okay. Now if I'd like to switch to that, I'd have to do change shell, CHSH-S for shell, $ for variable, open parentheses, which, and then Z shell. Okay. And I'm not going to hit enter because I don't actually want to switch shells, but that's how you would switch shells. Okay. And just be aware that there's other shells out there that are available to use. The other shell we can look at is going to be fish shell. So the fish shell, that's a tough one to say in a row. Fish shell is a smart and user-friendly command line shell for Linux, Mac OS, and the rest of the family. Fish is a more modern shell with the goal of being more interactive and more user-friendly than older shells. Unlike its competitor, Fish shell is based on the Bourne shell, is not based on the Bourne shell or the C shell, but attempts to blaze its own path. So Fish shell comes with some nice features such as auto-suggestion to type, syntax highlighting with extensive error checking, searchable command history, 256 terminal colors, advanced tab completion, web-based configuration. A special help command gives access to all fish documentation in the user's web browser. Error messages designed to actually tell the user what went wrong and what can be done about it. So normally you'll see in Linux it just says command not found or gives you very vague or general errors. Fish shell will actually give you a little bit more in-depth details about what happened. Universal variables, support for the X clipboard. And you can change fish settings by editing the home/.config/fish/config.fish file. There's also man page completions. It's fully scriptable with syntax that is simple, clean, and consistent. And it has features work out of the box without any configuration. Okay, so there's a lot you can do with fish shell features. I'm not going to go over it here, guys, just because, like I said, typically you're going to be working with bash shell. That's going to be the default shell for most people. And if we incorporate fish shell here, I think it's just going to add a little bit too much for you guys to realize. So let's go ahead and focus just on the bash shell for now. Let's go ahead and move on to command execution here. So the exec command in Linux is used to execute a command from the bash itself. So this command does not create a new process, it just replaces the bash with the command to be executed. If the exec command is successful, it does not return to the calling process. So we can see an example below. We have bash, okay, and we're going to do exec ls, and it's going to give us ls command, and then it returns itself back to the bash shell, okay. We also have startup files. Linux is a multi-user program, as we discussed before. It's a time-sharing system, and this implies that more than one user can log in and use the system. System administrators have the task of managing various aspects of how different users can operate a system in terms of installing, updating, removing software, programs they can run, and files they can view and edit, and so on. Okay? So really, a system administrator can actually alter the sudo rights. So you've seen me type in sudo on users. So you can actually alter and configure what commands users can run and what privileges they actually have using sudo commands. Okay. So when a user starts up their system, these commands are going to, or these files are going to be read, and it's actually going to apply that to their shell. Okay. These are known as startup files. You can also customize a user environment. So we can go into system login script, which is /etc/profile. We can do a personal login script, so we can call a variable home, which is just going to be the home directory, / and then .profile. We also have the shell startup script, which is going to give me the home directory /.bash profile, home directory /.shrc. Okay, so we can alter the user environments in those files. And here's a couple examples of different variables we can alter in the environments. We have JDK, JVM, as well as the path variables. We can set the user's terminal type. We can also customize the user's prompt. And we can set a default text editor for them. We can set up history file size and location. We can run reports as soon as you log into an account, and more. We can also set a command line shortcut and aliases. Okay, so these are all pretty advanced concepts, guys. We're just scratching the surface here. So we're going to go into more detail in intermediate and advanced Linux administration courses about the user environment, customizing variables in here. Just understand that as an administrator, you can actually alter a user's environment and limit them on what they can and can't do, as well as determine the defaults of their environment and how it looks and how they can interact with the shell. So in summary, we went over shell functions today, input and output redirection in pipes, command separation and grouping, background execution, file name expansion, shell variables, command substitution, quoting and escaping meta characters, Z shell features, fish shell features, command execution, startup files, and then customizing the user environment. In our next section, we're going to go over multitasking, schedule, execution, and using cron jobs, and the at and batch commands. Guys, please don't hesitate to follow these links here. If you're having issues or troubles with the things that you're learning, we have private tutoring sessions for system administrator, weekly and monthly plans, and we also have private tutoring sessions for Linux and Bash scripting. Thanks so much for joining me, guys. I look forward to seeing you in session 6 and 7. Hey guys, welcome to Session 7 of Introduction to Linux OS. My name is Kevin Downs, and as always, I'm excited to be your instructor for this series. Let's go and get started here. So today we're going to be covering multitasking and batch processing. So in session 6, we covered a lot of things, kind of just scratched the surface on them, really. So we went over input and output redirection in pipes, command separation and grouping, background execution, file name expansion, shell variables, command substitution, quoting and escaping meta characters, Z shell features, fish shell features, command execution, startup files, and finally customizing the user environment. Today, we're going to be covering multitasking, scheduled execution using cron, and the at and batch commands. So once again, we need to look at a little more at the multitasking environment in Linux and some of the data structures that make this possible. Because as we discussed in our last session, Linux is a multi-user system, which means multiple people and many people are going to be running processes and jobs on it. So the system needs a way to organize and take care of all these. So Linux and every other Unix variant manages multitasking by using a variable that keeps track of how much CPU time has been used by the task. And this variable is going to be IRQ, okay? And IRQ stands for an interrupt request. So each time an interrupt is sent to the IRQ, or interrupt request, 0, the variable decreases, and when the count is 0, the task has to be switched, okay? Or something needs to be done to free that up. So we see here in our little chart, in our little graph, we have our sleep queue. We have task interruptible and task uninterruptible, okay? So we have resources available, so the task runs, there's CPU available, CPU's running, and then coming back, we're waiting for the CPU and the task to run, and we're waiting responses, and then it's back in the sleep queue, okay? So every processing job is given cycles on the CPU, okay? It's given cycle time. It can only run when its time is available and up, okay? So let's look at scheduling execution using cron, okay? This is one way to kind of keep the resource usage low on your machine. You can schedule jobs using cron. So cron tab is found in a Unix-like operating system and is used to schedule commands to be executed periodically. Each line of the cron tab is separated by a job and contains information on when the job is to be executed. To view the list of cron jobs for a user, open terminal, run cron tab-L. To edit the list of cron jobs, run cron tab-E. So let's go ahead and look at that. So I'm going to do cron tab, C-R-O-N-T-A-B, space -L, or list. And you see there's no actual cron tab for me yet, but let's go ahead and do cron tab-E. And we're actually going to use, let's go ahead and use this, let's use the Vim basic one. Okay. You see there's a little bit of info here. You can read through that if you'd like. I'm going to go ahead and go all the way down and go into insert mode. So remember, we're in a Vim file right now. So to actually start typing in, I need to click I on my keyboard. Now I'm in insert mode. I'm just going to press down a little bit so we get a little bit more room on our screen. Perfect, okay. And now I can actually start adding jobs into our cron tab here, okay? I'm going to exit out of this, go back to our PowerPoint. So do escape, remember to get to command mode, and then colon. Okay, so escape, colon, and then Q exclamation point, because we didn't make any changes and I don't want it to save any changes. And I'll exit out, okay? Let me go ahead and clear my screen here. Let's go back to our PowerPoint. So how is cron actually set up? We see here in our next PowerPoint that the command opens the default editor to write or edit the cron tab. And cron jobs are written in the following format, okay? We have 1, 2, 3, 4, 5 placeholders here, and then the command to be executed, okay? So in this first placeholder here, this little asterisk or star, this represents the minutes, 0:59 in an hour. The second one, you see here, represents hours, so hours 0 through 23. Remember in Linux, everything's written in military time. And then the third placeholder here equals the day of the month, 1 through 31, okay? Not all months will have 31 days, obviously, but depending on the month you select, it will know which day you want. And then the fourth one here, we have months 1 through 12. And then the last one here, day of the week, 0 through 6, 0 representing Sunday. Okay? So let's head back to our virtual box here.
Thanks for watching. Please like and share this video.
My cron tab again. Go all the way down. Oops. Insert. We're just going to create a little space for ourselves here. Alright. So let's say that I want to create a job for, I don't know, let's say like 8:30 in the morning, the first day of the month in February on a Tuesday. Okay, so remember that first spot, it's going to be in a minute. So since we're doing 8:30, I'm going to do 30 minutes into the hour, space. I'm doing 8 a.m., so it's the 8th hour in the day, space. I'm doing February, which is the second month, so 2. Oops, sorry, I missed one here. So the third spot is actually the day of the month, okay, and I want to do the first day of the month, okay. And then it's month, so I'm doing February, so 2, second month of the year. And then day of the week, 0 through 6, okay, and I want to do it on Tuesday. Remember, 0 equals Sunday, so 0 would be Sunday, 1 would be Monday, and 2 would be Tuesday, okay. And then I would type in my command. So I could actually do, let's say I want to execute the, let's say I just want to do the date command. So I would just type in date. And that would be it. I can also type in a script I write up, so I can do /bin/bash, and then let's just say my script is called collect.sh, okay? So this would actually be the path of my script. So once it says time, day, month, and everything pulled up, it would run this script on that day, okay? Now if I wanted to keep those changes, I would have to write and quit, okay? So I'd have to do escape to enter command mode, write and quit. I'm not going to do that because I don't want this job to actually run. So instead, I'm going to do quit because I don't want anything to save. Okay? So that's how cron works. Let's go back to our PowerPoint and let's actually check out the command. So the command schedules a command to be run once at a particular time that you normally have permission to run, okay? So commands are only going to run one time. Cron jobs will run every single time for the date, time, and month, and etc. that you specified. The command can be anything from a simple reminder message to a complex script. You start by running the command at the command line, passing it the scheduled time as the option. It then places you at a special prompt where you can type in the command, or a series of commands, to be run at your scheduled time. When you're done, press Control-D on a new line, and your command will be placed in the queue. So here's an example of how the command works. We say at 9:30 p.m. Tuesday. It would then place us at a special prompt, which you see here. It would look like this. And then here we type in a simple echo command, which echoes a string of text. We would press enter, and we're placed at a new prompt. We then can press Control-D, telling that we're done with all our commands, and it then tells us our job is job number 1, and it will run next Tuesday. Okay. We could also do another example here at now in 10 years from now. Let's go ahead and go back to our virtual box. Let's just see how that works real quick. Oops. There we go. Let's clear our screen real quick. So we're going to do at 9:30 p.m. Tuesday. I'm going to hit enter. Okay, so is not actually installed right now, and it actually tells you if you want to use that command, you can install it this way. So let's go and do that. I'm going to grab this here, copy, paste. So I'm going to actually install that command. Yes, please install it. So it's installing the command here. See a little progress bar. And there we go, it's installed. Let's go ahead and clear my screen here, get a little bit of space back. Let's run that command again. At 9:30 p.m. Tuesday. And you see we get a special prompt here. So now we're at this little at prompt. We're just going to say, at that time, echo, hello, it is 9:30 p.m. Tuesday. And that's it. I just wanted to say, hello, it's 9:30 p.m. on Tuesday. It's just going to tell me that. I'll hit enter. And I can type in another command here if I'd like. Okay. But I'm just going to go ahead and press Control-D, say, hey, I'm done. It tells me, okay, job 1 at Tuesday, August 18th at 9:30 p.m. is going to execute. Okay. Let's head back to our PowerPoint. So that's how the at command works. That's how the cron command works. Okay. So that's just an efficient way to manage the resources and jobs on your system. Okay, if you need to run something every day or you need to run something every other day, you know a scheduled time that needs to be run. You can set that up ahead of time. That way you're not trying to run everything at once, and it's a little bit easier on your system and on your CPU. So in summary, we checked over multitasking today, scheduled execution using cron, the at and batch commands. On the next session, we're going to examine and compare files. We're going to report differences between files, compare files of any format. We're going to display data in octal and hex. We're going to look at compressing data. Don't be afraid to check out our private tutoring sessions for system administrators. We have weekly and monthly plans available. We also have Linux and Bash scripting, private tutoring sessions available. Thank you so much for joining me, guys, for session 7 here. I hope you learned a little bit. I hope you're starting to get comfortable with this system, and I hope you're having fun. I look forward to seeing you in session 8. And I'll see you later, guys. Hey guys, welcome back to session 8 of Introduction to Linux OS. My name is Kevin Downs. I'll be your instructor today, as always. So today we're going to be going over file processing utilities. Last session we went over multitasking, scheduled execution and usage of cron jobs, and we also went over the at and batch commands. Today we're going to be going over examining and comparing files, reporting differences between files, comparing files of any format, displaying data in octal and hex, and compressing data. Let's start off with examining and comparing files. There are several comparison tools that you can use on Linux. We shall look at some of the best terminal-based and GUI tools you can take advantage while writing code or other text files. We'll look at diff command. There's also the color diff command, wdiff. There's ls-alh command. Now remember, guys, this is the ls command with the flags alh. A stands for all, so show hidden files. L is a long listing, and H is human readable format. We also have ll, which is a shortened version of ls-l. And then we have the du command, which shows the disk usage. So we're going to take a look at the diff command only. Diff is a free, powerful file and directory comparator and merge tool that runs on the Unix operating systems such as Linux, Solaris, HP UX, IRIX or IRIX, DEC-True64. One limitation of diff is its lack of support for Unicode files and inline editing of diff files. So before we move on, let's go ahead and look at that diff command. So I went ahead and made some files already. You'll see diff1 here and diff2. Diff1, or diff2 and diff1. So let's go ahead and check out what's in those files. So we see we have line 1, 2, and 3. And then in file diff2, we have line 1, 2, 3, and 4. Okay. So let's go and run the diff command. So diff space the first file you want to compare, diff1, and the second file you want to compare, diff2. We see we get some output here, okay? So what this means is, on line 3, we need to add a fourth line, or after line 3, we need to add a fourth line for it to be the same as the second file, okay? Now at first it seems like that's not very helpful, but when we're running code, that's actually going to be very useful. It's going to tell us in this first file, something is different after that third line. Okay, we need to add a line to make it the same. So if I had a very long script or long file of code in both files, and it tells me after line 3 you need to add a fourth line to make it the same as this second file, that'd be very helpful. I could go to my first file, look at line 3, go to my second file, look at line 4, and see what the difference is, and be able to make them similar. Okay, this is helpful for debugging or troubleshooting when writing code. Let's go back to our PowerPoint here. Let's look at another tool. So the second tool we have is the CMP or compare tool. The compare utility compares two files of any type and writes the results to the standard output. By default, compare is silent if the files are the same. If they differ, the byte and line number at which the first difference occurred is reported. The optional arguments skip1 and skip2 are the byte offsets from the beginning of file 1 and file 2 respectively, where the comparison will begin. So let's check out that. We're going to use those same files again. Let me clear my screen. So I'm going to do CMP space, first file we want to compare, which is diff1, and the second file we want to compare, diff2. I'm going to hit enter. It's going to give us some output. So you'll see end of file EOF on diff1 after byte 21, line 3. So this is telling me at the end of file 1, which is diff1, after byte 21 and line 3, that there's a difference. Okay? So this is a little bit more specific, and I can actually hone in a little bit more using this compare utility. Alright, let's head back to our PowerPoint. So we're going to look at how to display data in octal and hex and decimal format here next. So the OD command in Linux is used to output the contents of a file in different formats, with the octal format being the default. This command is especially useful when debugging Linux scripts for unwanted changes or characters. So first we have the octal format, which will be OD space -B and then file.txt, or the file we want to do. Let's check that out. So we have OD -B, and then we're going to use that diff file again, diff1, and you'll see it displays it in octal format here. Okay. Next, we'll look at how to display it in hexadecimal format. So we have OD-AX, OD-AO, OD-AD. Okay. Let's go ahead and check those out here. One sec. Oops. There we go. Okay. So we're going to do OD dash capital AX, and we're going to use that diff1 file again. So you'll see it's there in hexadecimal format. We'll also do dash AO and dash AD. So you'll see slight differences here in this first column. These are all in hexadecimal format here. Last format we're going to look at is decimal format. This will be OD-capital I. So let's go ahead and check that out. So we have OD-I, capital I, in diff1 file again. And you'll see there, this is going to be in decimal format now. Alright, let's head back to our PowerPoint. So up next, we're going to look at compressing data using the tar command. The tar command is primarily used to bundle the required files or directories into an archive. Depending on the option used, we can also use the tar command to extract or list the contents of a tar archive. The syntax for using the tar command for archiving and compressing files is as follows. So we have tar dash cxtf, and then the file, and then the pattern. Okay. So I want you guys to go ahead and write what I'm about to say down. Okay, I'm going to tell you the flags for the tar command, the most commonly used ones. So I want you to write them down. First one is going to be C here, which is listed. This is for create. Next is X. X stands for extract. Next one's going to be verbose, which isn't listed here. Verbose means it's going to show the progress of the archive file. Okay. F, which we do have listed here, is file name.
Thanks for watching. Feel free to add your questions as comments down below.
So it's going to let you name that tar file name. And we have T that's also listed here. This is viewing content of the archive file. And then we have Z, which is a way to filter through archive through gzip. We have J, which is filter archive through bzip. Okay. So one more time, guys, go ahead and make sure you got these written down. C is create an archive file. X is extract an archive file. V, which isn't listed here, V stands for show the progress of the archive file, or verbose. F, which is listed here, stands for file name of archive. That lets you name the tar file name. T is to view the contents of an archive file name. So you can run T without actually extracting it and just see what's in it. J will filter archive through bzip, too. And then Z will filter archive through gzip. Okay. And then speaking of gzip, we have gzip and gunzip. So in order to compress files to save memory space, we use the gzip command. In order to uncompress the files, we use the gunzip command. The format for using the command is as follows. So we do gzip or gunzip and then the file. So guys, if you've ever used Windows or Microsoft, this is very similar to zipping a file. Okay, let's go ahead and check that out on our VirtualBox here. So I'm going to do an ls just so you can see what we have. I'm going to tar that diff1 file. So I'll do tar-create verbose because I want to see it as it does it. Okay. I'm going to run it through gzip, so I'm going to do z. Okay. I'm going to run it through gzip. I'm going to do f because I want to name the file, so file name. Okay. And so first, you're going to name the file, what it's going to be named to. So we're going to do diff1.tar. You always put .tar. And since we're running it through gzip, I'm going to put .gz. So this is the common nomenclature for naming. When someone sees this, they're going to know this is a tar file, and that's being run through gzip. If I were to have ran it through bzip, and remember that was J, I would actually name this bz. bz. Okay. But I'm going to keep it as gzip, because that's the most common way to do it. Okay. And then next, I would be telling it what to extract. Okay, so I'm going to do // I'm going to say diff1. Okay. So what this means is here, so in this current directory in diff1. So I'm telling it to tar the diff1 file. So I'm going to hit enter. And you're going to see it went ahead and zipped that diff1 file. Okay. I'll do an ls. And now we see that tar file there. Okay. What I'm going to go ahead and do is I'm going to remove that diff1 file. And if that were an important file, I'd be like, oh no, you know, I lost my file. But luckily, I have a backup of here, and I can extract it to this current directory. Okay, so I'm going to do tar extract, so -x, verbose because I want to see it as it does it. Okay. I'm going to put Z because it's a gzip file. Okay. And then I'm going to put the file diff.tar.gz, and I'm going to tell it where I want to extract it. I want to extract it to here, so /, which means here, this current directory. Okay, so I need to add the F option. There we go. Okay, so I do ls, and voila, I got my diff1 file back. So that's how you untar a file, so the -xvfz. And then how we tar a file, tar-cvzf. Okay? Let's go back to our PowerPoint. Actually, before I do that, let me show you gzip as well. Gzip is actually a little bit more simple. Let me clear my screen, get some space back. Gzip is a little bit more simple, so I'm going to do an ls so you can see the files. I'm going to do gzip diff1. That's going to gzip that file for me. Do ls, and you'll see diff1.gz. So obviously that's much simpler, guys. You know, you can certainly do that if you'd like to do that. And then to unzip that file, gunzip diff1.gz. I want to unzip that file. And you'll see there, well, actually let me remove it first just so I can show you it is actually unzipping it. So I'm going to do ls, you see diff1's gone, do gunzip diff, oh, that's all right, I need to gzip it again. Well, too late, I actually deleted it. So what I need to do, let me clear my screen. Let me do an ls so you guys can follow along where I'm at. So what I need to do now, I'm going to do it on diff2. So I'm going to zip diff2. Okay. So now you see I have a diff2.gz. Now I'm going to unzip that file. So you can see here there's no diff2 file. I'm going to unzip it. And you'll see there now I have my diff2 file back. Okay, so obviously gzip and gunzip is much simpler. So in summary, guys, we examined and compared files. We reported differences between files using diff and compare. We also compared files of any format, and we displayed the data of files in octal, hex, and decimal. We compressed data using gzip and tar, and we converted file formats. Next session, we're going to go over backup media, Unix device names, tar and CPIO, file transport and conversion with DD. Guys, please follow these links if you're needing a little bit extra help in our sessions, you're not quite understanding things. These links will take you to private tutoring sessions for system administrators. There you'll see weekly and monthly plans, and you'll also see private tutoring sessions for Linux and Bash scripting. Thank you so much for joining me, guys. I'm looking forward to seeing you in session 9. I hope you had fun, and I hope you're learning a lot. Hey guys, welcome back to session 9 of Introduction to Linux OS. As always, I'm your instructor, Kevin Downs. Let's go and jump into what we're going to be talking today. Today we're going over a very important topic of backing up files. Last session we went over examining and comparing files, reporting differences between files, comparing files of any format, displaying data in octal and hex format, as well as compressing data. And this is also another form of backing up data, so we actually went over some of the topics we're going to cover today. Speaking of what we're going to cover today we're going over backup media, Unix device names, tar and CPIO, as well as file transport and conversion with DD. Let's go ahead and jump right in with backup media. If you've ever suffered a hard drive crash, you know just how aggravating it can be. Irreplaceable data can be lost. Countless hours can be spent reinstalling operating system applications. It is not a fun experience, guys. And it needs to happen only one time for you to realize the importance of making regular backups of your critical data. So let's talk about Unix device names here. So Unix has a beautifully consistent method of allowing programs to access hardware. Under Unix, every piece of hardware is a file. To demonstrate this novelty, try viewing the following file, /dev/hda. To run this command, you're going to actually have to be root or run it as sudo. So we can run less-f/dev hda. And let's go ahead and jump to our VirtualBox and let's check out that now. So I'm going to log in here. Let me clear my screen. So I'm going to do sudo less-f/dev/hda. No such file. Actually, let me see what drives I have on here. Okay, so I have SDA. Let's do that. SDA. There we go. Okay, guys, and what you see here is a bunch of jargon and stuff we can't actually read. So what's actually happening here, let me jump back to our PowerPoint. What's actually happening here is you're reading directly from the first physical hard disk of your machine, okay? dev/dev/HDA is known as a device file, and all of them are stored under the dev directory, okay, guys? You'll notice in our VirtualBox, let me clear the screen here. Okay, so you'll notice here I actually had to type in SDA. Okay, since we're using VirtualBox, we don't have an actual hard disk on this machine. Okay, so what we actually had to do is SDA. Okay, so we have our first disk here, and it's labeled by A. If I were to add another disk, it would be SDB. A third disk would be SDC, and so on. Okay. On this first disk here, we actually see the different partitions underneath of it, SDA1, SDA2, and SDA5, okay? But don't worry about that for right now. Just realize that SDA is pretty similar to HDA. Let's head back to our PowerPoint. So let's go over the tar and CPIO commands. So we actually checked out the tar command in our last session. So tar is short for Tape Archiver. And tar is the most popular Linux backup tool. It's one that's most commonly used. It functions as both a command and standalone utility that responds to a plethora of commands. Tar's claims to fame lies in its ability to perform a wide variety of backup operations. With tar, you can execute full backups of servers and desktops or backup data to multiple devices. You can also perform network backups using command line tools such as netcat, NC, and SSH. And we went over the different flags and format for that in our last session. So let's go ahead and look at CPIO here. CPIO is short for Copy Input to Output. CPIO is one of the most versatile utilities in the Linux backup toolbox. The flexibility of CPIO gives it numerous advantages over other utilities. Unlike dump, it backs up entire file systems as well as individual files. You can back up with the tar to a single medium, but CPIO can simultaneously back up data to multiple destinations, okay? So this gives it a lot more versatility than tar. However, with that power comes greater complexity. CPIO has a much steeper learning curve due to its extensive command options, okay? So as we saw in the last session, guys, gzip was probably the easiest way to back something up, and tar was a little bit more complicated. Well, CPIO comes with even more options and complexity. Okay, so we're going to only briefly touch about how to use this. So just like tar, CPIO has some flags on it that are commonly used. So go ahead and get your pen and paper out, or pencil and paper out, and I want you to write these down. So just like tar, CPIO also has a -V option, which stands for verbose. It has a -O option, which is create. A -I option for extract. And that's really going to be the main ones for CPIO. Let's go ahead and go to our VirtualBox here. I'm going to give you a quick demo of how the syntax works. So if I wanted to create a CPIO backup, what I could do is I could do CPIO-IV. So I for create, V for verbose. And I would have to redirect archive to that command. So I would have an archive file here. I want to make a backup of that. So I have to redirect everything from archive to CPIO. Okay. I'm not going to do it because I don't have an archive file. I can try it on. Let's see. Let's see what files I got. I have diff2. Let's try diff2. Let's see if that'll work. CPIO-I for create and V for verbose. Redirect diff2 to CPIO. So let's see. Yeah. So the formatting isn't correct on there. But that is how you would run that command on there. If I wanted to extract, oh, I'm sorry guys, I mixed that up. So that's why it didn't work. I did I for create, I remembers extract. That's why it didn't work. So I need to do O for create. That's why it didn't work. There we go. Okay, so it should have created. let's see, what errors is this in? Cannot stat no such file. Okay, so again, it's just not liking the format of that file. Okay. Oh, I see what's going on here. Okay, hold on 1 second, guys. Let me start over here. So let me create. Let's just create.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
Create a new file here. Let's do like a ls command, and we're going to pipe that into cpio. We're going to do -ov. Okay, so O is create, V is verbose. We're going to say send that to the current directory. All right, is a directory. Okay, let's do. All right, let's just do /temp/object.cpio. There we go. Okay. Let's go ahead and head to that directory and see if it created that file for us. Alright guys, so I went ahead and created that file, and then I went to the temp directory, and you can see there that object cpio file was created there. Okay, let me clear my screen. Let's look how to extract that file now. So to extract the file, I would use cpio -I for extract, V for verbose, and then object.cpio. And now it'll extract everything out of that file into this directory, you see. Okay. Let me go ahead and clear my screen here. Alright, so as you can see guys, the cpio command is a little bit more complex. I just want to show you how that was used. I would stick with tar for right now until you get a little bit more familiar with the system. Let's go ahead and look at our next form of backup here, which is DD. So DD is simple yet powerful. DD is another OG Unix utility that Linux admins use. Now guys, OG here just stands for original gangster, okay? So it just means it's one of the original programs on the Unix system. What makes DD such a powerhouse is its ability to cover data protection in ways other backup tools can't touch. You can use DD to back up the entire hard disk or create partition backups or CD-ROM content. DD is restricted to the root user, and with good reason. If you're not careful, one wrong move with this potent command line tool could result in a permanent loss of data. Okay, guys? So admins actually often joke that DD stands for Disk Destroyer, okay? Because it really can mess up your data if you don't know what you're doing with it. So again, I would not mess with this command just now. I just want to show you kind of how it's used and what it's used for. So below, we kind of see the syntax here, how to use it. So we got to do sudo, because as it said, you need to be root user to use it. So we do sudo space dd, and we do an if statement. If equals dev/ada SDA. Then we're going to do the boot sector 512, account of 1, and we're going to say of the master boot record image. Okay, guys? So what this is saying we're going to create a backup of this disk. We're going to start at sector 512. We're going to do one count, and we're going to do it of this image. Okay, so we're actually going to the hard disk itself, and we're looking at the sectors and partitions of that disk and telling you exactly what to back up on that disk. Okay, so this is very unique and detailed, and this isn't something we can do with tar cpio, right? This is much more specific. However, you have to have very complex knowledge of the disk, and you have to know where sectors start and end and how that works. And that's why this can be very dangerous if you're not sure what you're doing. All right, let's go ahead and move on to the next slide, which is going to be our summary here. So we went over backup media. We went over Unix device names. We went over tar and cpio as well as DD. We went over file transport and the conversion with DD. Next session, we're going to go over the desktop a little bit and some more user tools that we can use with it, such as KDE menus, toolbars and tools, GNOME menus and tools, LibreOffice, which is very similar to Microsoft Office, so we'll have write, calculate, impress, math, draw, base. We're also going to have an introduction to Ubuntu and Debian. Guys, please don't hesitate to click on these links and follow them to our private tutoring sessions for system administrator management. There are weekly and monthly plans available, as well as private tutoring sessions for Linux and Bash scripting. These are super helpful and will help you get ahead much faster and really concrete your understanding for these topics if you're really wanting to get ahead and understand what's going on here. So please follow these links. As always, thank you for joining me. It's been a pleasure teaching you. I hope you're learning a lot, getting familiar with the systems, and starting to feel comfortable with the understanding of Linux and Ubuntu. I look forward to seeing you guys in our next session. Hey guys, welcome back to Session 10 of Introduction to Linux OS. As always, I'll be your instructor, Kevin Downs. I'm looking forward to having you in our 10th session here of Introduction to Linux OS. Today we're going to be covering desktop environments. Last course, we went over backup media, Unix device names, tar and CPIO, file transport, and conversion with DD. Today, we're going to be covering KDE menus, toolbars, and tools, GNOME menus and tools, LibreOffice, and its programs such as Write, Calc, Impress, Math, Draw, Base. We're going to also introduce you to Ubuntu and Debian. Let's jump right in with KDE here. KDE is an international free software community that develops free and open source based software. Well-known products include the Plasma desktop, KDE frameworks, and a range of cross-platform applications designed to run on modern Unix-like and Microsoft Windows systems. It further provides tools and documentation for developers that enables them to write software. This supporting role makes KDE a central development hub and home for many popular applications and projects like Calligra Suite, Krita, or Digicam. GNOME is a desktop environment composed of free and open source software that runs on Linux and most BSD derivatives. GNOME was originally an acronym for GNU Network Object Model Environment, but the acronym was dropped because it no longer reflected the version of the GNOME project. And guys, anytime you see GNU, most people are going to pronounce that or say that as GNU instead of saying GNU. GNOME is developed by the GNOME project, part of the GNU project. The GNOME project is composed of both volunteers and paid contributors, the largest corporation contributor being Red Hat. It is an international project that aims to develop software frameworks for the development of software, to program end-user applications based on these frameworks, and to coordinate efforts for internationalization and localization and accessibility of that software. So on most of these environments and desktops, you're going to notice they have LibreOffice, which has the following packages: Write, which is similar to Microsoft Word, Calc, which is similar to Microsoft Excel, Impress, which is similar to Microsoft PowerPoint, Math, which is designed for creating and editing mathematical formula, Draw, which is similar to Microsoft Visio, and finally Base, which is similar to Microsoft Access. Let's go ahead and check out a couple of those here on our Ubuntu desktop. So if you see here on the left-hand side, we see LibreOffice Writer right here. We're going to click on that, we'll open it, and you'll notice it's pretty similar to Word. So we've got some text editing options up here, formats, styles, things like that. Just going to exit out of that. We see Calc Spreadsheet here. And this is very similar to Excel Spreadsheet. Similar functions, similar style. You can also see Impress, which looks a lot like PowerPoint with slight differences. And we have Math, which we can use to create formulas, and Draw, which we can use to create and design things. And we got many others as well. If we also look on the left-hand side here, guys, we see a little Start button. And if we click on that, we can always search for things that we're looking for. So this guy right here. So in this top search bar, I can type in things that I'd like to find, such as calc, impress, and others. So if you're having trouble finding something, you can always click on this little start application bar and search there. To get out of this, we just hit escape. Let's head back to our PowerPoint. So Ubuntu is what we've been primarily using in this class on our virtual box. So let's go ahead and talk a little bit more in depth about Ubuntu. Ubuntu is a free, stable, and secure operating system that you can try out risk-free. Ubuntu comes at a tempting price and offers many of the advantages of popular commercial operating systems such as Windows and OS X, which is going to be Mac. But does its potential drawbacks, manual installation, and possible compatibility issues outweigh its benefits? To answer this, let's go ahead and look at how Ubuntu compares to the two best-known operating systems, which are Microsoft Windows and Apple OS X. The most obvious way is in the licensing and distribution terms. Ubuntu is free software, a term which is often misunderstood to mean only free of cost. While Ubuntu is free of cost, the term free software more accurately refers to the freedom to run the program for any purpose, to study how the program works, and to modify it to your needs, to redistribute copies, and to improve the program and release your improvements to the public. Ubuntu also includes many of the programs used for everyday computing at no cost, unlike Windows and OS X. It also offers Office Suite, a full Office Suite with a word processor, spreadsheet, presentation software that can read and write in doc, LXS, and PowerPoint formats. It can also output to PDF and supports for electronic office documents. So this is very handy when we're trying to communicating with people who are still on a Windows OS or maybe a Mac OS. So it allows for some cross play there. We also have a desktop email client, an email program with a similar interface to Microsoft Outlook. Let's go ahead and check that out real quick. That's going to be on our left-hand side here. That's going to be this little guy here, Thunderbird email. So when I open that up, you're going to see I have to set up my email address, which I haven't done, but it's going to be very similar to Outlook. We also have a web browser, Firefox, which is the increasingly popular web browser choice. We have databases. The best known open source databases on Linux are Postgres, SQL, and MySQL. But commercial databases such as Oracle and IBM's DB2 are also available. There are also tools like Glom that provide an easy way to use graphical interface for designing and editing databases. And there are also other advantages to Ubuntu. Ubuntu's online application guides list some Ubuntu-compatible applications that allow you to edit images, listen to and manage music, edit and watch videos, read PDFs, connect to instant messaging services from MSN, AOL, Google, Yahoo, and more. So let's head back to our virtual box. Let me show you here. So we can actually use Firefox here, which is just on the left-hand side. And you can even download Chrome on here if you would like. So it allows for you to pick web browsers that suit your needs. Let's go ahead and exit out of that. Close tabs. Let's head back to our PowerPoint. So let's go ahead and switch over our focus to Debian. Debian systems currently use the Linux kernel or the FreeBSD kernel. Linux is a piece of software started by Linus Torvalds and supported by thousands of programmers worldwide. FreeBSD is an operating system including a kernel and other software. And guys, we've been talking about Unix a lot, but Linux is really what most people are using now. Unix is something that isn't used quite often anymore. It's going to be very rare that you actually run into a Unix operating system. Instead, you're going to be using Linux primarily. There are many cases of machines that run for over a year without rebooting. Even then, they are only rebooted due to a power failure or a hardware upgrade. Compare that to other systems that crash multiple times a day. And guys, with my job here at IBM, I can vouch for this. There are many servers that I administer that we haven't rebooted in years. And typically, we don't want to reboot a server unless we have to, okay? Unknown to many, anything sent over the net can be read by any machine between you and the receiver. Debian has packages of the famous GPG and PGP software which allows mail to be sent privately between users. In addition, SSH or Secure Shell allows you to create secure connections to other machines which have SSH installed, meaning anything you send over that connection is going to be encrypted and it's not going to be in plain text, which can't be read. But don't take our word for it. Try Debian for yourself. Since hard disk space has become less expensive, you can probably spare about 2 gigabytes. If you don't want or need a graphical desktop, 600 megabytes is going to be more than enough to run Debian. So in summary, guys, we went over some KDE menu toolbars and tools. We went over some GNOME menus and tools. We went over the LibreOffice available on these desktops, such as Write, Calc, Impress, Math, Draw, and Base. And we also introduced you to Ubuntu and Debian. As always, guys, please don't hesitate to reach out and click on these links for some private tutoring sessions available for system administrator management. There are weekly and monthly plans available. There's also Linux and Bash scripting available with private tutoring
Thanks for watching. Please like and share this video.
Sessions. So we do have some more system admin training, and actually after this course we're going to do some homework assignments for you. But to enhance your learning and continue, you can look into Intro to Cybersecurity, Introduction to Cloud Technology, learn how to manage Windows servers. We have Introduction to Database Design, learn SQL programming by examples, Introduction to NoSQL Database Design, learn Graph Database Design by examples. We also have a comprehensive list of all Linux OS distributions available here at this link. We also have some more info on what is a Linux operating system and how it works. And we have a comprehensive review of Linux file system architecture and management at this link here as well. We also have a comprehensive review of how Linux file and directory system works, as well as a comprehensive list of all special purpose Linux distributions, in conjunction with a list of all secure Linux distributions for cybersecurity professionals. So some classes to take after this, guys, will be Learn PHP Programming, Intro to Linux Bash Scripting, which is also going to be taught by me. We have Linux Management for System Admins, which again is going to be a course that I teach and instruct, so I'd love to see you guys in both of these courses here. And then we have Intro to HTML and CSS. Thank you so much, guys, for joining us on Session 10 here. After this, we're going to be going over some homework assignment for you guys. I'll be taking you through those with examples and instructions how to do it. So be looking forward to seeing you there. Well, congratulations, guys. You completed your first course, Introduction to Linux OS. I'm Kevin Downs. I've been the one that's teaching these courses. I'm happy to have you guys along with us, and I hope you learned a lot by doing these courses. Let's go ahead and check out our final PowerPoint here. So these have been courses by codingbootcamps.com. Be sure to follow us on social media, and go ahead and go to our website, coding-bootcamps.com, for more courses. So this concludes Introduction to Linux OS. In this course, we learn Introduction to Unix, basic user commands such as move, copy, ls, cd, and others, text editing with VI and Vim, UNIX processes, the file system and how it works, introduction to shells such as Z shell and fish shell, and the default bash shell, multitasking and batch processing, file processing utilities, backup files such as CPIO, tar, gzip, and DD, as well as some desktop environments such as KDE, GNOME, and Ubuntu and Debian. So again, congratulations. You successfully finished this class. I hope you guys learned a lot. I hope you had fun. I hope you were able to learn a lot from me. I definitely encourage you to keep going. Search the web for any resources you can find. Continue to do hands-on projects. And more simply, you can follow up the classes that you've just recently finished with these ones here. The first one being Learn PHP Programming. The second, Intro to Linux Bash Scripting, which is another class that I'll be teaching. Third, Linux Management for System Admins, which again is going to be a class I'll be teaching. And Intro to HTML and CSS. Again, guys, thanks for joining me. Be sure to follow us on our social media sites. Be sure to go to our bootcamp website, coding-bootcamps.com, and I look forward to seeing you in our other courses. See you guys.